Hello, and welcome to Hacking Web Applications. Throughout the course, you're going to learn how to find out the vulnerabilities in a website, how to exploit the vulnerabilities and hack the application, and how to secure your application from these attacks. First, let's get prepared for the course and talk about some technologies and standards used in web applications. We need to learn how to collect information about the website. We're going to have to learn as much about the application as we can. And while discovering everything about the website, we analyze the configurations of the mechanisms used. We collect everything we find and try to use them to hack the app. The vulnerabilities and attack methods are classified according to OWASP. OWASP is Open Web Application Security Project, and one of the most important communities out there regarding application security. We manipulate inputs and push the application to produce unexpected outputs. Then, we compromise the authorization, authentication, and session management mechanisms of that application. You can use any virtualization platform, such as Oracle VirtualBox or VMware Player. While using virtual environments, the virtual machines should be on the same network to see each other. Now, we're going to use virtual machines in NAT mode. If you're using VirtualBox because of its architecture, you should create a NAT network. If you use a virtual machine in NAT mode without configuring any NAT network, a network is created for that virtual machine, and it doesn't see other virtual machines even if they are in NAT mode. If you're using one of the VMware tools such as VMware Player, Fusion, or Workstation, using NAT mode for network interfaces will be enough for the virtual machines to see each other. Oh, and I should probably tell you that since there are a lot of vulnerabilities in it, do not use the virtual machines in bridge mode, which are intentionally vulnerable, such as Metasploitable or OWASP broken web applications. If you use them in bridge mode, they will be accessible in the network where your host machine is. Someone in that network might hack the vulnerable virtual machines and try to access the host machine, which means your computer. Now, if you would like to use virtual machines in host-only network mode, please just learn how the virtualization platform works in that mode first. VirtualBox is a freely available open-source software solution. Runs on Windows, Linux, Macintosh, and Solaris hosts, and supports many guest operating systems. So VirtualBox is deceptively simple, but it's also very powerful. So let's go ahead and install it, give it a quick look. Hey there, so I want to make a particular hands-on demonstration in Windows for two particular reasons. One, I'd like to show you that the host is not critically important while preparing the lab. And secondly, I'd like the students using Windows as a host system to feel comfortable at the beginning of the course, because we're going to be using a Mac as a host system in general for the rest of the course. So simply by using your favorite web browser, type VirtualBox into the address bar. You will see the official site of VirtualBox is the first row of the results page. So it's virtualbox.org is the official site. So click on it. And on the left pane, there's the download menu item. So let's click it to see the download options. All right, so this is the latest edition when I was preparing the course. Now, there's a couple of options for the major hosts. So, by the way, what I mean about the host is that your main operating system installed on your computer. So click on the option, whichever is suitable for you. Right now, I'll use a Windows 10 machine as the host. So I'm going to download for Windows hosts. And while downloading VirtualBox, just scroll your mouse down a little bit and you can see that there's an extension pack to install as well. The extension pack helps your installation support different things like USB 2 and 3 devices. It's not an obligation, but it may help you to manage your installation easily. Now click on the link All Supported Platforms. Wait a little bit. Might not take too much time. All of it has been downloaded. Go to my Downloads folder. Double-click on the X file. Click Next, Next, Next. And now it will install some virtual network adapters at this phase. So click Yes and Install. Now it's going to be installing for a while. And there it is finished. I don't want you to start now, so let's uncheck the box and click Finish. See, now's the time for installing an extension. After installation of VirtualBox, the icon has changed. You see that? So double-click on it and wait for a bit. Right, so now this screen comes up. Click Install. So go ahead and scroll down until the end, and you'll see that I agree button. It's enabled. So click on it if you agree, and, well, you should agree in order to use VirtualBox. So wait a second. Okay. So now you're done. Congratulations, you've installed VirtualBox. So please have a look and be familiar with the menus by yourself before you start. VirtualBox.org is the official site. And on the left pane, there's the Download menu item. So in the Downloads page, we have platform packages here. Click on OS X Hosts as a link for Mac devices. Now select the appropriate location for the installation package and click Save to start the download. When the download's finished, double-click on the installation package file, which has the .dmg at the end. Okay, so here you do what the instructions tell you. Double-click on the VirtualBox.package icon, click Continue, continue again, and Install. And then here I just enter the local admin password and click the Install Software button. Now, go to the Applications menu and click the VirtualBox icon to start your virtualization environment. Congratulations, you've installed VirtualBox. Go to VirtualBox Preferences, select NAT Networks under Network segment, and create New NAT Network. Then, go to Virtual Machine Settings. On the Adapter 1 tab under Network segment, attach the virtual machine to NAT Network and choose the NAT network you created. So now, let's provide connectivity between your virtual machines. So the way I'm going to do this, I will include all of my virtual machines in a NAT network. I'm first going to start with Kali, so I'll choose it, click Settings, go to Network Settings, change NAT to NAT Network, right? And click OK. Now I'll do the same thing for the other virtual machines quickly. So, Kali Linux is a Debian-based Linux distribution aimed at advanced penetration testing and security auditing. Kali contains several hundred tools which are geared towards various information security tasks, such as penetration testing, security research, computer forensics, and reverse engineering. Kali Linux is developed, funded, and maintained by Offensive Security, a leading information security training company. Now, we're going to use Kali as the attacker system. However, if you don't want to use Kali for whatever reason, you can download the tools that we use and install them to your host machine. So let's download it and install it as a virtual machine on our host system. I'm going to prepare Kali VM directly from the VMware image first. The first step is to download the VM files. Open the browser and simply Google the words Kali and download. The first website is the official site of Kali, so click on it. This is the download page of Kali. These are the ISO files. You can use them to install Kali as the main host or as a virtual machine in any virtualization platform. There are both 64-bit and 32-bit versions, and light versions, which are about 3 times smaller than the original one. There are also some other ISO files for different desktop environments, KDE, LXDE, XFCE, etc. Kali uses the GNOME desktop environment by default. So if you're familiar with any other environment, you can just go ahead and download that ISO and use it as well. At the bottom of the Kali image files table, there are ready-to-use, almost ready-to-use Kali virtual machines. So if you're going to use Kali as a virtual machine, you can use them instead of installing ISO files from scratch. I'm just going to use one of these images now, so I'll click on this link. So now we're in the Virtual Images page. Scroll down a bit, and here are the images. The VMware images are on this tab. The first link is a zipped archive. You have to extract it after the download. Let me show you what you'll have after you extract it. I'm in the file browser of my host machine. Virtual machines are under the Documents folder, and here they are. This is the Kali VM that I currently use, and these files are what you'll have when you extract the 7z archive file. Here you can simply run the VMX file to run the VM. Now I'd like to show you how to install Kali from the OVA file. So I'll click on it to download. If you're not familiar with it, an OVA file is a virtual appliance used by virtualization applications such as VMware Workstation and Oracle VM VirtualBox. It is a package that contains files used to describe a virtual machine, which includes an OVF, Open Virtualization Format descriptor file, optional manifest, MF, and certificate files, as well as a bunch of other related files. So the second step is to install Kali. Well, since we'll use the OVA file, it'd be better to say import for this step. And the download's finished. So let's look at the file location. It's under the download folder. Now I'll open the VMware Fusion interface. From the Add button at the upper left corner, choose Import. Click the Choose File button and choose the OVA file you just downloaded and click OK. As you see, VMware Fusion read the file and detected the VM as Kali Linux 2018.1. We can click Continue for the next step. Now it's asking for the location of the VM. And this folder works for me. Now I think it's better to collect all the VMs in a folder so you can manage them easier. It will create a single file with this name. Now click Save. And it starts to import. It may take a couple of minutes. So I want to look at the size of the empty space on my host. I'm in doubt whether I have enough space. df command simply displays the free disk space, and -h parameter makes the result human readable. I have 34 gigabytes of free space, and that will be enough for this installation. Installation's finished, and this is the summary of the VM. RAM is 2 gigabytes by default, and if you have enough RAM on your host system, I suggest you increase it. Networking is NAT at just as I want. Okay, click Finish to finish the installation of Kali VM. Now it's asking if you want to upgrade the VM. I say, okay, why not? So our new Kali is booting for the first time. And we're here at the login screen. Let me make the VM full screen. Okay. This is a previously prepared VM, so it comes with the tour password for the root user. So enter root for the username and tour as the password. And welcome to the Kali 2018.1. So let's open a terminal screen and check the network connection. If config to see the obtained IP. ETH0 interface didn't obtain an IP. So that means we have a problem. No worries, that's what we're going to fix. Problems do occur, and that's what we do. We solve them. So now we're on the last step. Fix the problems and run Kali. Now, in the previous lecture, we installed Kali and ran it for the first time. And we had a problem with the network. Now, we'll fix the problem and make Kali ready to use. First, let me reboot the machine. I want to understand whether the problem is an exception for the initial run or not. So I shut down the virtual machine because I want to look at the settings of it. Now, this is the VMware Fusion's virtual machine library. Select the Kali and click the Settings button. Click Processors and Memory. I want to make the RAM 3 GB. So now I can click the Start button to boot it again. Now let me look at the network adapter while it's booting. Click on Network Adapter. Internet is shared in NAT mode, and that's what I want. Root as the username, tour as the password. Okay, we are in again. So let's check the network connection by clicking the network icon at the upper right-hand corner. It says connecting, but it cannot. So I think there's a problem on the DHCP of the VMware on my host. Well, anyway, we can live without DHCP as well. But you probably won't face such a problem and see the network as soon as you run Kali. However, I want to show you that problems occur and don't give up. We can get rid of them. So I'm looking at the wired network. Don't be confused, even though you share the wireless connection of your host machine, it's simulated as a wired network in the VM. So let's open a terminal screen and look at the networking service if it's running. Write Service Networking and press Tab twice to see the available commands of the service. Networking service does not have status command, so I'll assume that it's not started and try to start it. Still seems to be connecting, but it is not. So now I go to Wired Settings, click the wheel icon under the Wired tab. Okay, I go to the IPv4 tab to set the IP manually. Click the Manual option. I'll choose an IP for the new Kali. Now, the IP block of my virtual network is 172.16.99.0/24. So I'll choose an IP from this block. Netmask is 255.255.255.0 for a 24 IP block. And as far as I remember, the gateway is 172.16.99.2. Let me look at another VM's network settings. So this is Kali I'm currently using. Go to Network Settings, select Wired Settings. Click the wheel icon under the Wired tab. Go to the IPv4 tab. Yes, the gateway is correct. So I'll use 8.8.8.8. That's the Google DNS as my DNS server. And route. Okay, let's leave it as automatic. Now click the Apply button at the upper right-hand corner. Now go to the terminal and check the network again. Restart the networking service. It still seems to be connecting. If config, to check if it obtained an IP. Nope, no chance. Okay, I'll reboot the machine to be sure that the changes are applied. You can use reboot command in the terminal screen to reboot the machine. Boot completed. Looks like it connected. So open a terminal screen, type ifconfig to see the IP address of the new Kali. It's 225, just as we said. So let's ping a remote system, for example, Google DNS 8.8.8.8. Yes, we received the response packages. The network's okay now. So to double check, open a browser and visit any website. As the target systems, we will use OWASP Broken Web Applications, or BWA. Now, Broken Web Applications is a virtual machine that hosts a lot of applications prepared for training purposes. These apps are intentionally have a lot of vulnerabilities and can also be accessed from a main page. The virtual machine is prepared by OWASP Open Web Application Security Project, which is one of the most important communities around in the application security market. So I'm now on my host machine. It's a MacBook. Open a web browser and Google for OWASP, Broken Web Applications. Those are my keywords. The first website is the official website of the Broken Web Applications Project, hosted under the OWASP.org domain. So let's click it. Now, this is the web page of Broken Web Applications. I'll call it BWA from now on. So there are some explanations about this project here, so you can read them if you want. But over here on the right-hand side, we have download the latest release. So click on that. Now we're directed to the SoundForge website. So these are the side effects of GDPR. We'll have to see a lot more approval pages like this one. Okay, so these are all the releases of the project, and the latest version is right here at the top. So click on it, and now I have 3 different options to download: .ova file, a .zip file, and a .7z file. Now, an OVA file is a virtual appliance used by virtualization applications such as VMware and Oracle VirtualBox. It's a package that contains files used to describe a virtual machine. Zip and 7z are the archive files, and they contain the exact same VM. So you can download any one of them where the 7z file is smaller. Okay, so I want to download the 7z file, which is the most popular one already. So click on the link and download will start in just a couple of seconds. There we go. And the download's finished. So now I have an OWASP BWA archive file. So I'll open it with an unarchiver and double click, and here are the files inside the archive. So I already have the VM, so I won't extract it again. When you extract it, you will have a folder like this. So go to the folder, and here are the files of the virtual machine. If you run the .vmx file, double click, the VM starts. If it's the first run, it asks you whether you moved it or copied it. Select Copied and continue. Right, so while the VM is starting, let's have a look at its settings by clicking this button. Click here to look at the memory. 1024 megabytes of RAM is recommended. Click Show All to turn back to the settings. Network settings are here. So my VM is in an unrecognized network mode. Don't pay any attention to that. Your VM is probably in NAT mode by default. I choose Share with my Mac so that I can use the VM in NAT mode. So now the VM has started and we're ready to log in. It has a root user with the password OWASP BWA by default. I haven't changed it before, so I'll log into the VM by using this credential. If configured, it check if it has got an IP address, and there it is, so yes it has. Now, ping a system on the internet. Google DNS, for example, 8.8.8.8, and we'll receive the replies. So it seems everything's fine, and we're ready to use OWASP Broken Web Applications VM. Before we start, let's be sure that the virtual machines see each other. So start up the virtual machines and log into them. If you didn't change the credentials before, you can log in with the default credentials. The default credential of our test system are as follows. The default username of Kali is root, and the password is its reverse, tour. And OWASP Broken Web Application has root as the user, and its password is OWASP BWA by default. So first, let's learn the IP address of each machine. In Linux distributions such as Kali and Metasploitable, open a terminal screen, type ifconfig, and press enter. The IP address which is seen in the ETH0 interface is what we want. In a Windows system, you can learn the IP address running ipconfig in the command line. So in your host machine, you will see more than one IP address for your system. You will see an interface with a name like vmnetx. This is the IP address that we use to interact with the virtual machines. Oh, and by the way, it'll probably be the first IP address of that IP block. And then ping the other virtual machine. So you should see a terminal screen similar to the screen seen on the slide. At least packet loss should be less than 100%. Now, some systems, such as Windows 8, may not be allowed to ping by default. I mean, if you ping a Windows 8 machine in, for example, Kali, you may not get the expected result even though the systems see each other. If you can ping Kali in Windows 8, it's enough to understand that the systems are in the same network and that they see each other. If you don't get this result, please check the virtual machine settings again. The IP addresses of the virtual machines should be in the same IP block, which means if one of your virtual machines has an IP address like 172.16.99.123, the IP address of the other virtual machine should be like 172.16.99.222. So now we are ready to start the hands-on practice of the course. In this phase, you should be able to reach the OWASP BWA application inside your Kali machine. So go to Kali, open Firefox browser, and type the IP address of the OWASP machine with the HTTP prefix. If you don't want to memorize the IP address of the application to enter each time, or if you want your test more realistic, you can give a domain name to your application, go to /etc/hosts file, and enter a line for the application machine, IP address of the application, space, a domain name to reach the application, save the hosts file, and close. Now, you can reach the application with the domain name you gave in hosts file. Before starting to learn about finding vulnerabilities and exploiting them, let's see some terminologies and standards used in web application platforms. To be able to understand if there is a vulnerability on an input field, you should send thousands of different payloads. For example, you have to try hundreds of payloads to be sure that there is not an SQL injection vulnerability in a field. There might be tens or hundreds of input fields in a web application. If you want to test the application manually, you may spend months. To make it faster, you should use automated tools. There are a lot of automated tools you can choose. Some of them are commercial, such as AppScan, Fortify, Acunetix, NetSparker. In addition, there are some free tools such as W3AF and Z Attack Proxy. And as a side note, some of the commercial tools have a free trial period so that you can see if they're right for you. Now, let's see how the automated tools work. The automated tool sends a request prepared for a purpose. The application returns a reply for the request, and then the tool analyzes the response to see if there's a weakness. They can send tens of requests in seconds. The first step to understand how the web applications work is to know client-server architecture. Systems that want to get services are called clients, and the systems to serve the clients and to host the application are called servers. Clients, in most cases, are web browsers. In some cases, you can see client-side applications other than browsers communicating with the servers using web protocols. These applications are called thick clients. Now, even though there is a thick client on the client side, it's still a web application, and you will be able to hack it at the end of this course. Usually there's a database server at the back end. In this slide, you see some of the technologies and standards used in each layer. You don't need to know everything about the technology in detail, but it's better to know which are used in the application, so we're able to focus on the technology used. For example, if we try to exploit a SQL injection flaw and know what the database management system is, suppose that it's Oracle, then we just use the keywords and methods of Oracle. Make sense? Hypertext Markup Language, HTML, is the standard markup language for creating web pages and web applications. The building blocks of HTML pages are HTML elements. HTML elements are delineated by tags written using angle brackets. Browsers do not display the HTML tags, but use them to interpret the content of the page. Here you'll see some of the HTML elements important for us, and you can see here how to reach resources, input fields, and tags to use scripts. This is a simple HTML page example. If you look at the source of this page, you will see the page source contains the tags shown in the second frame. H1 is for header, bigger and bolder. P is for the paragraph. UL is to start a bulleted list. LI is for the list items. URL, Uniform Resource Locator, is a reference to a web resource that specifies its location on a computer network and a mechanism for retrieving it. The components of a typical URL are: scheme is the protocol used by the application. Schemes occur most commonly to reference web pages, but are also used for transferring files, emailing, and many other applications. Host consists of either a registered name, host name, or an IP address. A typical host name consists of subdomain, domain, and top-level domain name. Port is separated from the host name by a colon. This is the port number where the application is served. If it's not given, the default port numbers are used. The default port numbers are 80 for HTTP, 443 for HTTPS, and 21 for FTP. Path is usually organized in hierarchical form that appears as a sequence of segments separated by slashes. Query is separated from the preceding part by a question mark and contains a query string. A query is most often a sequence of attribute value pairs separated by a delimiter, and the delimiter might be an ampersand or semicolon. Parameters which will probably determine the response are sent to the server in this section. Fragment is separated from the preceding part by hash. The fragment contains a fragment identifier providing direction to a secondary resource, such as a section heading in an article identified by the remainder of the URI. HTTP, Hypertext Transfer Protocol, is an application protocol. Hypertext is structured text that uses logical links between nodes containing text. HTTP is the protocol to exchange or transfer hypertext. HTTP is a stateless protocol. That means no information is retained by either sender or receiver. HTTP functions as a request-response protocol in the client-server computing model. A web browser, for example, may be the client, and an application running on a computer hosting a website may be the server. The client submits an HTTP request message to the server. The server, which provides resources such as HTML files and other content, returns a response message to the client. The response contains completion status information about the request and may also contain requested content in its message body. The most used HTTP request is GET. A GET request is designed to request server resources. With these types of requests, the parameters are sent to the server inside the URL. you see two different HTML elements which will cause GET requests. POST request is designed to request server resources, as well as GET requests. But unlike GET requests, parameters are sent to the server inside the body of the request, instead of the URL. It's still possible to send the parameters inside the URL, but if you use POST request, you should prefer sending parameters inside the body to URL. In this slide, you see the HTML elements to send a POST request. What's that, you ask? What's the advantage of sending parameters inside the body instead of URL? Good question. Almost always, the traffic between the server and the client is logged on the server side. Such log files usually contain the URL. If you send the parameters in URL, they are saved as clear text in your log files. So anyone who can see the log files can also see your sensitive parameters. You should use POST requests to send sensitive data, but please make a note that it's not enough for the privacy of the traffic, because any man in the middle who listens to the network will see the parameters, even though they're inside the body of the request message. So you should encrypt your traffic. The server, which provides resources such as HTML files and other content, returns a response message to the client. The response contains completion status information about the request and may also contain requested content in its message body. Every response has 3-digit response status codes. Responses with a code starting with 1 are informational responses. An informational response indicates that the request was received and understood. It is issued on a provisional basis, while request processing continues. It alerts the client to wait for a final response. The message consists only of the status line and optional header fields, and is terminated by an empty line. Responses with a code starting with 2 mean success. This class of status code indicates the action requested by the client was received, understood, accepted, and processed successfully. Responses with a code starting with 3 mean redirection. This class of status code indicates the client must take additional action to complete the request. Many of these status codes are used in URL redirection. A response with the code starting with 4 shows that there is an error that seems to have been caused by the client. For example, if the requested resource is not found on the server, you get a 4XX coded response. 5XX coded responses mean that the server failed to fulfill an apparently valid request. HTTPS consists of communication over HTTP within a connection encrypted by TLS, Transport Layer Security, or its predecessor, SSL, Secure Sockets Layer. The main motivation for HTTPS is authentication of the visited website and protection of the privacy and integrity of the exchanged data. There are a few questions we should ask about using SSL or TLS. Does the application have a version working without SSL? If it has, the user might be tricked to connect over HTTP, or an attacker can perform an SSL strip attack to turn an HTTPS connection into an HTTP connection. Which versions of SSL or TLS are allowed by the server? The older versions of SSL and TLS have weaknesses, so it's not safe to use them. Has the certificate of the application been signed by a valid certificate authority? Which algorithms are used for encryption, and are they strong enough? There are tools such as SSL Scan and SSL Digger to test the SSL or TLS configuration of the server. You can find the tools in Kali Linux. In addition, there are some browser plugins to analyze the SSL or TLS of the application. You can try Calamel or Komodo SSL plugins for Firefox. So even though it might seem a bit off topic, we can quickly see how a typical encrypted connection between the server and the client is established. The client sends the information that the server needs to communicate with the client using SSL. This information contains a client's SSL version number, cipher settings, session-specific data. The server sends the information that the client needs to communicate with the server over SSL. The server also sends its own certificate. The client uses the information sent by the server to authenticate the server. Using all data generated in the handshake thus far, the client creates the pre-master secret for the session, encrypts it with the server's public key, and then sends the encrypted pre-master secret to the server. The server uses its private key to decrypt the pre-master secret, and both the client and the server perform a series of steps to generate the master secret. Then they use the master secret to generate the session keys, which are symmetric keys used to encrypt and decrypt information exchanged during the SSL session and to verify its integrity. The client then sends a separate message indicating that the client portion of the handshake is finished. The server sends a separate message indicating that the server portion of the handshake is finished. All right, so now we're getting there. A personal proxy gives you a direct view into how your target application works under the hood. It operates as a web proxy server and sits as a man in the middle between your browser and destination web servers. This lets you intercept, inspect, and modify the raw traffic passing in both directions. If the application employs HTTPS, the personal proxy tool breaks the SSL connection between your browser and the server, so that even encrypted data can be viewed and modified within the proxy. So here's a demo. Setting up the personal proxy and your browser to work with each other involves the following elements. First, we need a proxy listener to accept requests from your browser. We can use Burp Suite for this purpose, which is embedded into Kali Linux. By default, Burp Listener uses port 8080. Second, we need to configure our browser to use the proxy listener as its proxy server. We can change the proxy settings of our browsers from the following menus: Preferences, Advanced, Network, Settings. Or even simpler, we can use plugins such as Foxy Proxy to change the proxy settings with a single click. When you install the plugin, a Fox icon appears next to the address bar. Since Burp Suite Listener listens to the port 8080, we redirect the traffic to that port. Now, let's see how we intercept the traffic and modify the requests. Go back to Firefox. Foxy Proxy is disabled at the moment. Visit http://nhs.uk or whatever you want. Now, open the Burp Suite. In Burp Suite, make sure that the Intercept mode is on. Go to Intercept tab under the Proxy tab and see the Intercept button is on. So back to the browser and select the personal proxy for port 8080 from the Foxy Proxy plugin. Type green, or whatever you want, into the search box in the upper right-hand corner and press enter. The response is caught by Burp Suite. Find the word we search for in the request, change it, for example, yellow, press the forward button. Now there will be following requests for the resources of the website which we're not interested in, so we can turn the intercept off at this point to avoid time loss. Go back to the browser, and as you see, we sent green to search, but since we changed it using a personal proxy, we have a different result now. If you try any website which uses HTTPS protocol, such as google.com, you probably got the message that your connection is not secure. To be able to intercept the traffic, Burp Suite handshakes with the website, and we handshake with Burp Suite. Since we haven't added the Burp Suite certificate as trusted, you get that message. Go to Advanced and add Exception. Then you can keep going. Burp Suite makes the handshake with the website, and we make the handshake with Burp Suite.
Let's see the best way to intercept HTTPS traffics using Burp. The safest way to intercept HTTPS traffics is to install the PortSwigger certificate on your browser. PortSwigger is the owner of the Burp Suite tool. First, let's delete if we have any previously installed PortSwigger certificates. If you didn't try to install a PortSwigger certificate before, you can ignore this step. Open Firefox. Now, from the menu button at the upper right side of Firefox, follow the path to open the certificates list. Preferences, Advanced from left, Certificates, and click View Certificates button. Look at the first if there is any PortSwigger certificate and delete it if there is. Now it's time to run Burp Suite. Configure the browser to use Burp. For this purpose, from the Foxy proxy icon, I choose location host 8080, which is designed to listen to port 8080 of the local machine. Type http://burp/ in the address bar of Firefox. Click CA certificate, link at the upper right-hand corner, and save the file. It's now saved in the download folder on my computer. Now let's import the download certificate. Again, from the Firefox menu, follow the path to reach the certificate page. Preferences, Advanced, Certificates, and click the Import button. Choose the certificate you downloaded a few seconds ago. Check Trust this CA to identify websites, at least, and click OK. Now it's time to intercept an HTTPS traffic. I'll intercept the traffic of google.co.uk page. Go to the Burp Suite. As you see, the intercept is on and the request is caught by the Burp Suite. To test if everything is okay, I'm going to search for a word, intercept the traffic, and change the word with another one. I write OWASP in search bar and hit enter. Burp caught the request. I replace the word OWASP with CI security and turn the intercept off to allow the traffic flow. When I go back to Firefox, I see that the word CI security has been searched instead of OWASP. It works like a charm.
Here is the classification of web attack types. It's based on OWASP Testing Guide. OWASP, Open Web Application Security Project, is a worldwide not-for-profit organization focused on improving the security of software. It means you collect information about the app, attack surfaces, application users, etc. as much as possible. This information is used to determine the attack method. It's a good approach to test the configurations of each mechanism while information gathering. The configurations may cause weaknesses, and those weaknesses might be used to hack the app. Then, data exchanged between the client and the server is manipulated. The application is forced to make mistakes. We analyze what the application does in unexpected situations. Authentication mechanism is a critical part of an app. We'll try to find out the flaws of the mechanism. If the application has more than one user type, authorization problems may appear. We manipulate user rights and roles and try to do something that we are not allowed to do. Session management mechanism is the next target. The session is the unique identifier of the user, and the person who steals the session of a user can act as that user. Business logic flaws are not found by the automated tools. Analyze the procedures of the app carefully. Tamper with the procedure flows, change the order of procedures, etc. Automated tools are an important part of pen testing of a web application. To be able to understand if there's a vulnerability on an input field, you should send thousands of different payloads. For example, you have to try hundreds of payloads to be sure that there is not an SQL injection vulnerability in the field. There may be tens or hundreds of input fields in a website, so only for the SQL injection vulnerability, you have to give hundreds of thousands of tries in a typical web application pen test. So if you want to test the application manually, be my guest. It it's going to take months. So to make it faster, you should try using automated tools. The OWASP ZAP proxy, otherwise known as ZAP, is one of the world's most popular free security tools. It can help you automatically find security vulnerabilities in web applications. So to answer your first question, what is OWASP ZAP? ZAP is a tool to find the vulnerabilities in web applications. It's completely free and open source. Because of the ease of use, it's ideal for people new to application security. ZAP is also a cross-platform tool, so you can use it on Windows, Linux, and Macs. It's easy to install. It requires Java to run. Everything else is included in the standard download packages. A full set of help files is included, and these can also be viewed on the web. And ZAP is a community project, so there are hundreds of volunteers to improve it and to add new components on it all the time. ZAP provides the essentials that you'll need for testing web applications. First of all, it's a personal proxy to intercept and tamper with the HTTP and HTTPS traffic between the browser and the server. It provides both active and passive scanners. The passive scanner just examines the requests and responses, and it can detect certain types of vulnerabilities just on that basis. It runs all the time you use ZAP, and it's safe to use on any site as it does not perform any attack itself. And on the other side, Active Scanner performs a range of attacks. So as you see in the next lecture, spidering or crawling can be used to crawl the application. For example, to find pages that you've either missed or which have been hidden from you. ZAP can generate reports on the issues it has found, including advice and links to more information about the problems. It can also fuzz parameters, and you can use fuzzing to find more vulnerabilities that the automated scanners can't necessarily find. So let's see how to install and perform the first scan using the Quick Scan option. First, let's see how to download and install OWASP ZAP. In a browser, I search for OWASP ZAP, so ignore the Google advertisements on top. But the first link is the link to OWASP ZAP proxy. OWASP's ZAP proxy pages have a lot of helpful information about the tool. So by clicking Download Now, it brings us to the GitHub page of the OWASP ZAP tool. Here you have some packages and installers for different platforms. So you can choose the appropriate one and click it to download. Now, because I want to use ZAP with my Kali, I'll download Linux installer or package. So I'll choose the Linux installer. Now here, as you see, I already have the package downloaded before, so I'll ignore this step. But importantly, the Linux installer link brings you the file with the .sh extension. And when you analyze it with a file command, you'll see that it's an executable shell script. To run it, type / and the file name inside the folder. But hold on. The file does not have the execution rights by default. So to make it executable by everybody, type chmod 755 file name. Now it's executable. And we can type / and file name to install ZAP. But since it's already embedded in Kali, I'm not going to need to install it again. So to use OWASP ZAP, type OWASP-ZAP in anywhere and hit enter. Or open the Applications menu and type OWASP to find the tool and click its icon to start ZAP. As you see, the downloaded version and the embedded version are the same. So that means we have the current version of ZAP in our Kali. So now it asks if you want to save the ZAP session. I'll choose no. No worries, you can save the session whenever you want. So now let's see the Quick Scan option of ZAP. In the Quick Start tab, enter the URL address of the application you want to scan, and click the Attack button to start the scan. First, the spider runs to crawl the application, and at the left pane of the ZAP's user interface, you'll see the discovered pages of the application. So now there are yellow or orange flag icons next to some of the pages and folders. That means ZAP has already found some medium and low-level vulnerabilities. So look at the Alerts tab. You'll see all the vulnerabilities found by now. And as we said before, ZAP runs the passive scan all the time you use it, so it's always running in the spidering phase as well. Now look at the Damn Vulnerability Web Applications folder, DVWA. You see, the only page discovered is the login page. The application allows us to see only the login screen if we don't log in to the app. ZAP doesn't have any valid session or credentials, so it can only find the login page of the DVWA app. And here you can stop or pause the spidering phase by clicking any of the buttons inside the Spider tab. And to make the demonstration faster, I'll stop the spidering phase now. So as soon as the spidering phase finishes, ZAP starts the active scan phase. In the Active Scan tab, there is a button to show the scan progress details. And, same as spidering, you can stop or pause the active scan phase by clicking the corresponding button. And in the Alerts tab, we'll see the numbers of the findings are increasing. So let's look at the scan progress details. At the left side of the panel, there are the names of the vulnerabilities tested by ZAP. The recs column show the number of requests sent to test that vulnerability. The progress column shows the current status of the progress for that particular vulnerability. And you can stop or cancel any test for a vulnerability by clicking the small button at the right side of the row of that vulnerability. ZAP continues to the next vulnerability test. Here, it finds some vulnerabilities in high severity level. It's a reflected XSS. Don't worry, we'll see the vulnerability in detail. So here's the request sent to test the reflected XSS vulnerability. Now here's an important warning about the automated tools. The findings of the tool might be a false positive. A false positive is where you receive a positive result for a test when you should have received a negative result. So it sometimes is called a false alarm. So you have to verify any finding. So now let's see if the script code executes in this XSS test. It's a GET request, so there is not any particular parameter in the body. We can simulate the attack just by copying and pasting the URL of the test request. Now, see how the script runs. The finding is a true positive. So I think that's enough. I don't think there's any need to wait until the end of the scan. As I said before, one of the main features of the Z attack proxy is, not surprisingly, being a personal proxy. You can use it as a personal proxy to intercept and tamper with the HTTP and HTTPS traffic between the browser and the server. We have already seen a personal proxy by now, which is Burp Suite. And the interception feature of ZAP works a little differently from Burp Suite. So let's see how ZAP intercepts the traffic. So I'll want to start a new session to avoid the complexity. From the File menu, I'll select New Session and click OK. Now let's go to the Options panel. To open the panel, you can use the Options icon from the menu bar, which looks like a wheel. Alternatively, you can select options from the Tools menu, or you can even use the key command Control-Alt-O to open the Options panel. So at the left side of the Options panel, select Local Proxies. Here you see the local proxy address, which is the local machine by default, and the listening port, again, 8080 by default. ZAP starts to listen to the port 8080 when it's started. So click OK to close the panel for now. And let's check to be sure if the port 8080 is open. Open a terminal screen. Use netstat-tnlp to list the TCP ports, which are in listening mode. And as you see, the state of the port 8080 is listen, and a Java application, ZAP, is listening to the port. Okay, so let's open a browser window now. Here is Firefox with Foxy Proxy plugin installed. So right-click the Fox icon. We have already defined a proxy for the port 8080, the local machine. Select the proxy. And now visit a website. Make sure you visit an HTTP page. We'll see intercepting HTTPS traffic with ZAP in the next lecture. So I'll visit OWASP Broken Web Application. As you know, www.owasp.bwa.com is mapped with the IP address of my OWASP BWA virtual machine. And visit a page on the OWASP BWA website. I click, for example, OWASP WebGoat link. So turn back to ZAP. You'll see that www.owaspbwa.com folder is created, and it has a WebGoat subfolder in it. So now let's visit another page on the website. Click Damn Vulnerable Web Application. In the ZAP window, we have another subfolder for DVWA now. In Firefox, I log into DVWA and visit the XSS Reflected page. Here it asks my name, and when I enter the name and click Submit, it says hello. So go to the ZAP window. There's another subfolder with the name Vulnerabilities under the DVWA subfolder. And here are the visited pages. I find the request for Reflected XSS page, right-click on it, and select Break, and click Save. Now there's a Breakpoints tab in the bottom pane, and the link of the XSS Reflected page is here as a breakpoint. So now go back to Firefox again and revisit the XSS Reflected page. And as soon as we click the link, the ZAP window becomes the active one. Look at the right pane. There's a new tab pane called Break. And here is the request sent by the browser. Now there are buttons on the menu bar. This one submits your changes on the request and steps to the next packet. And this one submits your changes and continues to the next breakpoint. Remember that difference. Now, click them to release the traffic and go back to the browser. Now, on the Reflected XSS page, I'll write Jack as the name and click Submit. So again, request is intercepted by ZAP, and here it is. I find the name parameter, convert Jack to William, and click the Submit and Continue button. So now go back to the browser. As you see, we submitted Jack from the browser, but the result is Hello William. So as a web application penetration tester, you'll always encounter HTTPS sites. So you should know how to intercept HTTPS traffic as well. Fortunately, it's easy to intercept HTTPS traffic using ZAP. So here I am with the browser where the port 8080 of the local host is selected as the proxy. And when I visit an HTTPS page like google.com, Firefox says that our connection is not secure. Well, remember when we saw this before, we were talking about intercepting the traffic using the burp suite. So to be able to intercept the traffic, ZAP handshakes with the website, and we handshake with ZAP. Since we haven't added the ZAP certificate as trusted yet, you get that message. So let's go to the ZAP window and open the Options panel using the button with the wheel icon in the menu bar. And on the left pane, select Dynamic SSL Certificate option. So as you see, there's a root CA certificate for OWASP created before. So we can use it or click the Generate button to create a new one. Now click the Save button and save the certificate anywhere you want. Click Save, click OK to close the Options panel. Now let's add the certificate just like we learned before. In Firefox, open the menu using the menu button at the upper right corner and select Preferences. Select Advanced from the left, choose Certificates tab, and click View Certificates, and the Certificate Manager panel open. Click Import. Select the certificate you saved a few seconds ago. Now, in the Downloading Certificate panel, select at least the first option. Trust this CA to identify websites, and click OK. OWASP ZAP is added as a trusted authority. Now we're ready to capture and intercept HTTPS traffic. So in Firefox, visit an HTTPS page again, and as you see, no problem occurs. Now in the left pane of the ZAP window, you'll see the HTTPS web pages captured by ZAP. So let's talk about the most important feature of ZAP. Of course, it's scanning. We've already seen the quick scan feature of ZAP. So now let's have a look at scanning with ZAP in depth. First, I'll want to scan Damn Vulnerable Web Application DVWA without a valid user or session. So to start a new session, from the File menu, select New Session. In Firefox, while the port 8080 of the local host is selected as proxy, visit the OWASP BWA website and click Damn Vulnerable Web Application link and go back to the ZAP window. So here, a subfolder for DVWA is created as we expected. Right-click the folder. So in the Attack submenu, select Spider to crawl the application. And there it is, the spidering is finished in almost milliseconds. But as you know, DVWA allows you to only visit the login page if you haven't logged into the application. So ZAP can only crawl the login page and some images and cascading style sheets, and that's about it. So if you start the active scan in this situation, all the attack modules will run on the login page only. So you can only find out the vulnerabilities of the login page. So sure, the attack is completed in under a second, but only because a single page has been scanned. So when you look at the Alerts tab, you can only see a few medium and low alerts. But we know that the application is damn vulnerable, and there are a lot of high-severity vulnerabilities. So what we have to do is create a valid user or session so that we are able to scan more. So let's start over. Exit and rerun ZAP for a brand new start. Now go to the browser, configure the proxy as the port 8080 of the local host, and visit the DVWA application. I'll log into the application using admin credential and visit a few pages on the app. So go back to the ZAP window. Here is the subfolder of DVWA, the login page, and the visited pages. Did you recognize the yellow flags next to the pages and folders? Remember, ZAP runs the passive scan all the time you use it, so it's running now and reporting the findings. Look at the Alerts tab below. So before creating a new context, it's better to talk about some of the contexts of ZAP. Contexts are a way of relating a set of URLs together. So you can define any context you like, but it's expected that a context will correspond to a web application. So it's recommended that you define a new context for each web application that makes up the system you are testing, and set them in scope as you test each one. Now, right-click the DVWA subfolder from Include in Context submenu. Select Default Context to add the application into the default context. The Session Properties panel opens. By clicking the root node of the default context, you can change the name of the context with an appropriate one. Click OK to close the Session Properties panel for now. So as you see, the DVWA subfolder and the files in it are marked with a red sign. So you can open the Session Properties panel at any time using the button in the menu bar. Let's click the button to open the panel again. Here we have some details of the context. For example, click the Session Management option. You see the currently selected session management method for that context. In the Authentication option, we're supposed to select the authentication method. The authentication method of DVWA is form-based authentication. So I leave it with the default values for now and click OK to close the panel again. Now, find the login request on the left side. You see the parameters in the parentheses. Right-click on it under the Flag as Context submenu. Select Form-Based Auth Login Request option. Session Properties panel appears. And as you see, the authentication method is selected as form-based authentication. And the configuration fields, such as login form target URL, are filled automatically. Well done, ZAP. Here we should select the correct parameters. Username parameter for the username and password parameter for the password. Click OK to close the panel. Now reopen the Session Properties panel. So do you see that the login request post data is prepared to be able to use it with different username and password pairs? But before closing the panel, let's enter one or more valid credentials of the application. So select the Users option under the Context node. The admin credential is already collected by ZAP. So once again, well done. Click the box to enable it. Click Add to add another credential. Give it a name. Enter the username and password values and click Add. So now 2 credentials are added and enabled. So just under the Users option, there's another option, Forced User. You can select a user here which will be used for all the requests made for this context, only if the Forced User mode is enabled. Click OK and close the panel. So looking back at the menu bar, here there's a button to enable Forced User mode. It's disabled by default, but click the button to enable the Forced User mode. Now let's go to the Session Properties panel once again and select the Authentication option. There are 2 other options at the bottom of the page. While crawling or active scanning, ZAP will try every single link and field. And during these tries, it will probably log out the application. And in these cases, the application will understand the logout and then re-log into the application to be able to keep going. So that means we have to teach the application when it's logged in or not. And for this purpose, we should find something which can only be seen in the private pages. And by that, I mean the pages you can only access if you're logged in. So close the panel. Find a page which is accessible only if you're logged in. For instance, index.php. Go to the Response tab and look at the body. Select a part of the body. This part looks good. Select the pattern, right-click from Flag as Content submenu, select Authentication Logged In Indicator. So the Session Properties panel appears again, and this time, Rejects pattern identified in Logged In response message is filled in with our selection. So close the panel. Now we're ready to attack the app. Select the DVWA subfolder, right-click on it. There are several options under the attack menu. Of course, we should spider the app first. So in the spider panel, select the user, context is already selected, and click the Start Scan button to start the spidering phase. And spidering is finished in seconds. So now we have some alerts in the Alerts tab, which have been collected by the passive scan module of ZAP. And we have some new pages in the left-hand side of the app tree. Here there's a subfolder named Vulnerabilities, and there are more pages inside the folder. So go to the History tab. We see a lot of consecutive authentication attempts. It seems that something went wrong. But never give up. One of the most important things in penetration testing is being patient. You'll encounter a lot of different problems in a test, and you should fix them or find other ways. So let's have a look. We may have made mistakes when assigning input values, login URL, logged in pattern, or credentials. Let's go back and look at the application tree again. Oh, wait a second. Are these requests to change a password? While crawling the application, ZAP tries ZAP word in every field. Unfortunately, in the DVWA application, there are a few pages to change the password, and these pages only ask the new password and confirmation of the new password. They should have asked the current password. But this is a damn vulnerable application. So the password change attempt looks like it's unsuccessful on Captcha page, because it also needs the Captcha to be validated. And when we look at the request for the CSRF page, we see that ZAP sends ZAP word for both the new password and confirmation of the new password. So it seems like a valid password change request. So now let's look at the body of the response now. Here is the password changed message. It looks like ZAP has changed the password of the admin user accidentally. Well, is it true? Did the password of the admin user really change? So I go back to the browser, log out of the app, and try to log in again using the admin credential. Nope, no chance. Just as we guessed, ZAP has changed the password. So let's try to log in with the ZAP password. And to show you the password I enter, I'll use a small trick. Right-click on the password field. Select Inspect Element. Change the type of field as text. Now enter ZAP into the password field and click Login. Yep, password of the admin user is ZAP. So how about a little summary? What the heck happened during the spidering phase? On the CSRF page, ZAP filled in the fields with ZAP keyword. There are two input fields on the CSRF page, new password and the confirmation of the new password. Since they are the same, it was a valid password changing request. When ZAP clicked Submit on the page, the password of the current user, admin, has changed. When ZAP logged out of the app, for example, by clicking the logout link, it tried to log in again, but because the password is no longer admin, it failed to re-log in. And it was the end of the spidering phase for authorized pages. So a huge warning comes in here. If you're testing the real application, you're always a potential threat to change or delete some important values. You have to be very careful, and beyond that, you should include the critical pages from the automatic scans. So, let's reset the database of DVWA so that the password of admin user will be admin again. Click Setup button, and then click the Create Reset Database button to recreate the database tables of the DVWA application with the default values. Now the password of the admin user is admin again. So I'll log out of the app and re-log in using admin values. So to avoid the password changes on the next phases, I'll exclude the page which changes the password. So find the CSRF page, right-click on it, and in the Exclude From submenu, select Scanner. The URL is added to the Exclude From Scanner list, so the scanner module will not visit the CSRF page and does not change the password. So now we're ready for the active scan phase. Right-click the DVWA subfolder. From the Attack submenu, select Active Scan option for this time. In the Active Scan panel, select the user which will be used during the scan. Context is already selected. Click Start Scan and let the show begin. So that scan took longer than an hour. And depending on the network speed and the size of the application, a scan may take several hours. So go to the Alerts tab. You see the vulnerabilities found. And as expected, there are several high-severity vulnerabilities such as path traversal, SQL injection, XSS. But don't worry, we'll see them in detail. Let's first analyze the path traversal alert. As we said before, automated tools generate some false positives. So we should verify the findings to see if the vulnerability really exists. The request used to find the path traversal vulnerability is a GET request. Here is a payload. Now, it seems ZAP tried to reach the password file under the etc. folder. And let's look at the response by clicking the Response tab. And there you see the body of the response contains the content of the password file. And here are the users of the system which hosts the DVWA application. So if you double-click an alert in the Alerts tab, you see the details of the finding. Here, there's a long description of the vulnerability. And here is the solution. And these are the references to learn more about path traversal. And this is the attack parameter. It's called payload. This is the evidence of the finding found in the response body. In this section, we're going to learn about the app as much as we can. While discovering the app, we analyze the configurations of the mechanisms used. We collect everything we find and try to use them to hack the app. The first step of information gathering is to surf the app as long as we can. Visit each page. Try to click on all the links you see, all that. We can gather a lot of information about the app and the server while analyzing HTTP headers of the requests and responses engaged between the server and the browser. In addition, we can find some clues, especially for the data manipulation section, while analyzing responses which are sent for our targeted requests. Also, we should look for the open ports of the server. For example, there might be a content management system hosted by another port of the server, where we can get the management of the entire app. After surfing the whole app and learning its purpose and mechanisms, first we should intercept the connection between the browser and the server and analyze the headers of the requests and responses. We can find some information about the server, the technology used, etc. In addition, we can find some clues for the flaws of the app. For example, the cookie in the slide contains an attribute value pair which is security equals high. What if I just replace high with low or none? Look at the headers. If there is any header specific to this app. If there is, note that header, because that's the one you're going to tamper with. So far, we've gathered as much information as we can. Now is the time to look for the known vulnerabilities of the server or the technologies that are used, frameworks, plugins, software languages, etc. You can use the vulnerability databases and exploit databases to find the known vulnerabilities. One of the most famous databases is Exploit Database. The URL address to visit Exploit Database is https://www.exploit-db.com. Exploit-DB is the exploit database archive of Offensive Security, who are the producers of Kali Linux distribution. So, suppose that we realize the server is Apache 2.4.3. Visit a vulnerability database and search if there are known weaknesses of that version of server. Crawling, or spidering, is traveling through the website and collecting data about it. We can pull data from the application like email addresses, sensitive data, backup or forgotten pages, etc. Now, because we have to send a lot of HTTP requests, automated tools and scripts that are called crawlers or spiders are used to crawl a website. All the automated tools have their own crawlers. Burp Suite, that we use, has its own spider too. You may encounter interesting situations during crawling. For example, software developers create a copy of the file in the same directory for backup, or they may have a test version of the file which contains a valid credential in it. In some cases, they just turn the line which contains credential values into a comment line. But those comment lines are visible at the client side. That means when you look at the page source in the browser, you see the comment line which contains a valid credential. You can find an administrative interface that does not have a link through the website. And having no link to the interface does not mean that it's unreachable. So here's a demo. Let's see the spider tool of Burp Suite in action. Run Burp Suite. Turn the intercept off. We just want to have some links under the HTTP History tab. Go to the browser. Configure the proxy settings to use Burp Proxy. Visit the website you want to crawl. In this example, use nhs.uk. Now, go to HTTP History tab under Proxy tab. Select the root request, right-click, and select Spider from here. You can answer yes if you're faced with a question. And when you select the option, the font color of the Spider tab turns orange. That means there are changes in the tab since your last visit. Go to the Spider tab since you see some statistical information, request made, request queued, forms queued, etc. When you go to Sitemap tab under the Target tab, you will see the current results, files, and folders of the application. So, while configuring a web app, one of the common mistakes is to give too much information inside a message. Let's analyze a few examples from a security point of view. Suppose that you are trying to log into the system, and you are compromising the username and password fields, and you don't know any valid username and password. You have a dictionary to try on both the username and the password fields. Your dictionary contains 1,000 words. You will try 1,000 passwords for each username. So theoretically, you have 1,000 times 1,000 tries. Now, if you see this message after an attempt, it probably means that you found a valid username. Now we can just focus on the password field, and this reduces the number of attempts from 1,000,000 to 1,000. When you see this message, you understand that the username is controlled by the app independently. So forget about the password in the beginning and just focus on the username. When you find the username, try to find the password of that user. So you only have 1,000 plus 1,000 attempts in this case. This is another helpful message for the hacker. If the message is like this, you have no clue. You have to try every possible user and password combination. In some cases, you can see an error message like this. The developer probably prints the stack trace for debugging purposes. You can collect a lot of sensitive information with such a message. In this example, you will see that the application is written in Perl, version 5.8.8. The operating system of the server is Linux, etc. You get the point. So, what is all this information we gather? Everything that we retrieve from the server or the app is information we can use. HTTP headers such as server or X powered by headers, error and warning messages that we saw some examples on the previous slide. Comment lines of the web pages may contain sensitive data. We talked about that before. Email addresses of the employees or employers. We can use those email addresses to guess the usernames of login pages, or we can use them for social engineering attacks. These are only some of the examples of the information that can be gathered from an application. While the search engines are the most typical examples of crawlers, and they let us run queries on the website, we can use the search engines to find out the sensitive information and weaknesses of an application using search engines. Google has advanced search techniques. There are a lot of keywords to use while Googling. Some of them are displayed in this slide. You can find a lot of different queries in www.exploit-db.com/google-hacking-database address. So using these previously prepared queries, you can find weaknesses, documents which contain usernames and passwords, sensitive folders, web services, error messages which contain sensitive data, and backup and/or log files. So here there are just a few examples to show how we can use Google Advanced Search to find valuable information. For example, if we do a search with the words inurl:/co.uk and inurl:/admin, we can find administrative panels of the websites which have .co.uk superdomain. There are a lot of queries to find the critical points of an application. Thankfully, there are tools to automatize these queries for us. Search Diggity, Foundstone Site Digger, and Foca are just a few examples of these kinds of tools. Input and output manipulation is the most important part of hacking websites and web apps. The two most well-known vulnerabilities, XSS and SQL Injection, are the subjects of this section. If the inputs and/or outputs of a website are not adequately validated, they might be the subjects of exploitations. But before we start talking about input and output manipulation, we should understand a few terms and policies first. One of them is same origin policy. A web browser permits scripts contained in a first web page to access data in a second web page, but only if both web pages have the same origin. This policy prevents a malicious script on one page from obtaining access to sensitive data on another web page through that web page's document object model. Thanks to this rule, website A cannot access the session ID of website B. An origin is the combination of protocol used for the communication, entire host name, and port. Let's have a look at a few pages and see if they can access useme.js file. This page can access the useme.js script because of the protocol, host, and port are the same. Remember, if we don't specify the port, the default port is used, and the default port for HTTP protocol is 80. This page cannot access the script resources. The host names are different. Be careful, www.app.com is not the same as app.com. These are two different domains. In most cases, you go straight to the www page, even though you don't put it into the URL. For example, if you write google.com in the address bar of a browser, you reach the www.google.com page. Now, that doesn't mean that these two addresses are the same. That means Google servers redirect you to www.google.com address when you try to reach google.com. And look at that. The ports are different. JavaScript is a high-level interpreted programming language. Alongside HTML and CSS, JavaScript is one of the three core technologies of World Wide Web content production. It is used to make web pages interactive and provide online programs. It's the JavaScript codes that run the browsers. The majority of websites employ it, and all modern web browsers support it without the need for plugins. JavaScript can be used in an HTML file in three different ways. You can write JavaScript codes into a different source file and call it from the HTML page. You can write script codes into the HTML file using script tags. You can write script codes in event handlers. So everything exchanged between the browser and the server are inputs or outputs of the web application, text or edit boxes on the web page, headers of the request sent to the app, hidden fields, or even the header that does not exist in the original request might be an input field for the application. To minimize the risk of threats, one of the most important principles is validation of input and output fields. When the input source is not reliable 100%, the input is not reliable and shouldn't be used inside the system before validating. Client-side input validation is done by scripts, JavaScript, VBScript, etc. The main purpose of client-side controls is the performance. Users are warned about their mistakes before sending their requests to the server. From the security perspective, client-side controls can easily be bypassed. Remember, we are able to intercept the traffic between the browser and the server using personal proxies, for example, Burp Suite. So let's see another way to bypass client-side controls. We leave a message to a friend's guest book, but the max length of the message field is 50. We want to leave a longer message. Right-click, Investigate Element, and increase max length value. Now, we're able to leave a longer message. So for this reason, client-side controls are good for performance. In addition, server-side controls have got to be done for security reasons. While validating input parameters, we can talk about two different approaches. In the first approach, we have a blacklist. In the second approach, we have a whitelist. The first approach does not allow the inputs which exist in the list. The second approach only allows the inputs which exist in the list. The first approach is called negative data validation, and the second approach is called positive data validation. The first approach, negative data validation, is dangerous, and it's not advised to use. First, the number of malicious inputs are theoretically indefinite. Developers should think of every possible form of the characters, capitalized, encoded, or escaped. Seriously, anything you can think of. Secondly, developers should be careful about the algorithm of the sanitization method. Output validation is as important as input validation. Outputs which are sent to the client should be sanitized just before they're sent by the server. Even if we validate inputs, we should validate outputs as well. The output prepared to be sent to the client on the server side may have turned into a harmful value. Encoding, also known as character escaping, is an effective approach for both input and output validation. If you encode the special characters, they're not going to be interpreted and just printed out. For example, we have a blog, and we would like to publish a post that includes these lines. While testing for XSS, first try this. We prepared this page. Show the page without HTML encoding. When we call the page, we get the message on the screen because script tags are interpreted by the browser and the script runs. If we encode the smaller than character, it's no more a tag starter. It's just a character to print out now. Escape smaller than character, save the file, call it from Firefox, show the result. Cross-site scripting, abbreviated as XSS, is one of the most common vulnerabilities of web applications caused by inadequate input and output validation. It's an attack in which malicious scripts are injected into otherwise benign and trusted websites. XSS attacks occur when an attacker uses a web application to send malicious code, generally in the form of a browser-side script, to a different end user. Flaws that allow these attacks to succeed occur when the web application uses input from a user within the output it generates without validating or encoding it. An attacker can use XSS to send a malicious script to an unsuspecting user. The end user's browser has no way to know that the script should not be trusted and will execute the script. Because it thinks the script came from a trusted source, the malicious script can access any cookies, session tokens, or other sensitive information retained by the browser and used within that site. These scripts can even rewrite the content of the HTML page. Let's see the details on the different types of XSS flaws. Reflected XSS is also known as non-persistent XSS. These types of flaws occur when user input is immediately returned by a web application in an error message, search result, or any other response that includes some or all of the input provided by the user as part of the request, without that data being made safe to render in the browser, and without permanently storing the user-provided data. The attacker prepares the HTTP request and sends it to the victim, for example in a phishing email. Since the link is to a reliable website, the victim does not suspect the link and clicks on the link. The application sends the output produced, using the input sent by the victim as a responsive user request. The code sent in the response is interpreted in the victim's browser. So let's see the reflected XSS in an example. We'll use Damn Vulnerable Web Application for this example. Go to the OWASP Broken Web Applications homepage. You can use the IP address of the OWASP virtual machine, or if you defined a domain name in /etc/host file, you can use that name as well. Click the Damn Vulnerable Web Application link and log into the application using user/user credential and go to XSS Reflected page. So on this page, there is an input field asking the name of the visitor. When we submit our name, the application says hello. As you can see, the application produced an output using the user input. To examine if the application validates the input, we submit an input which includes a tag. Tag is not displayed. There might be two reasons for it. Either the tag is sanitized or it's interpreted by the browser. So go to page source and search the tag. Here it is. The input was not sanitized regularly. Now, try to send some script code. And done. The output contains the script, and the script is interpreted by the browser. Since the output is not stored and just reflected by the server, the attacker has to convince the victim to click on the link, which will cause the production of the malicious output. Stored XSS, also known as persistent XSS, is the most dangerous type of XSS. Stored XSS generally occurs when user input is stored on the target server, such as in a database, in a message form, visitor log, comment field, etc. And then a victim is able to retrieve the stored data from the web application without that data being made safe to render in the browser. The attacker prepares the HTML request and sends it to the server. The server stores the input sent in the request. Anytime a visitor visits the page which contains the output produced using the malicious request, the tampered page is returned to the visitor. Since the malicious code is stored in the server, the attacker does not have to convince anyone. Every visitor is a victim now. So let's see the stored XSS in an example. We use Damn Vulnerable Web Applications for this example. Go to the OWASP Broken Web Applications homepage and click Damn Vulnerable Web Application link. Log into the application using user/user credential. Go to Stored XSS page. Now this is a guest book which stores visitors' messages. When we submit our message, it's stored and displayed to the visitors in each visit. As you see, the application produced an output using the user input. To examine if the application validates the input, we submit some script code with the script tag. And done. The output contains the script, and the script is interpreted by the browser. Since the script is stored on the server, it will be sent whenever the page is visited or to whomever visits the page. Of course, the attacker is able to do way more than just giving alert messages. Let's prepare a message to collect the victim's cookies. So for this time, we create a new image in the script. We reached the max length of the edit box, but we already know how we can keep going, so let's change the max length of the box. Set the image source as attacker.com, so the victim sends a request to attacker.com to get the image. We give document.cookie as the parameter of the request, which sends the victim's cookie to attacker.com. Now at this point, let's watch the traffic between the browser and the server using Burp Suite. As you see, the victim's browser has sent a request to attacker.com and sent the cookie of the victim as the parameter. Now the attacker has a list of cookies which contains the cookies of all visitors. If you have the session ID of a user, you can act as that user in the application. So here's a nifty example from the real world. Remember when MySpace was big? MySpace is a site for keeping up with friends, meeting new people. It allows you to set up a profile and web page with a limited ability to make it look and feel how you want it. In 2005, Sammy Kamkar has decided to make his MySpace profile cool. After a little bit of messing around, he found that he could put in a longer headline than what they allowed. And of course, he put cool effects onto his page. Then he put a code to his profile, which does two major things. First, anyone who viewed his profile who wasn't already on his friends list would inadvertently add him as a friend. Second, the code added itself to the visitor's profile. Now that means anyone who views their profile also adds Sammy as a friend. And then anyone who hits those people's profiles adds Sammy as a friend, and so on and so on. So if 5 people viewed his profile, that's 5 new friends. If 5 people viewed each of their profiles, that's 25 more new friends. MySpace, Werman, Sammy Kamkar, Hikayesi, https, sammy.pl/popular/. Okay, so let's have a look here. Before the code is added, Sammy has 73 friends. 1 hour later, Sammy has 73 friends and 1 friend request. 7 hours later, he has 74 friends and 221 friend requests. 1 hour later, he has 74 friends and 480 friend requests. An hour after that, he has more than 500 friends and more than 500 friend requests. 3 hours after that, he has 2,500 friends and more than 6,000 friend requests. 5 hours later, he has 2,500 friends and more than 917,000 friend requests. 3 seconds later, more than 918,000. Another 3 seconds later, more than 919,000. And a few minutes later, he has more than 1 million friend requests. And after a while, Sammy's profile is down for maintenance. Before talking about the DOM-based XSS, I should tell you a little something about the Document Object Model. So DOM, Document Object Model, abbreviated as DOM, is a cross-platform and language-independent convention for representing and interacting with objects in HTML. The nodes of every document are organized in a tree structure called the DOM tree. DOM-based XSS can be thought of as a subclass of reflected XSS. The malicious data does not touch the web server. Rather, it is being reflected by the JavaScript code fully on the client side. Now, in reality, these 3 XSS types overlap. You can have both stored and reflected DOM-based XSS. You can also have stored and reflected non-DOM-based XSS too. But since that's confusing, so to help clarify things, the researchers proposed using 2 new terms to help organize the types of XSS that can occur. Server XSS, client XSS. Pretty simple, huh? The Browser Exploitation Framework, also known as BEEF, is a penetration testing tool that focuses on the web browser. Amid growing concerns about web-borne attacks against clients, BEEF allows ethical hackers to assess the actual security posture of a target environment by using client-side attack vectors. So let's use the BEEF framework with stored XSS. Let's go to Kali, run Firefox, and connect OWASP Broken Web Application using its IP address, or if you defined like me, using the domain address, and click the Damn Vulnerable Web Application. Log into the application using admin or user credential. Click XSS Stored Link. Now we already know that this page includes stored XSS vulnerability. Let's see it again rapidly. Now I go to my host machine, which is a Mac, open a browser, and connect to OWASP Broken Web Application. Now, because the domain name is not included into the hosts file of my host machine, I connect to the application with its IP address this time, and click Damn Vulnerable Web Application link. When I click XSS Stored link, as it's supposed to be, the script embedded by the Kali user runs. This is the nature of the stored XSS. Go to the home page of the DVWA for now, and let's turn back to Kali. So now's the time to start Beef by clicking its icon. We have to run the script code shown in the hook line inside the victim's browser. So I'll copy the code now. The Beef interface runs in just a few seconds. Log in using Beef credential, and go back to the DVWA tab. Now I'll prepare a new message that will contain the hook script of the Beef framework. Right-click and paste the code. Here we should write the IP address of the Beef Control Center, which is our Kali machine. Let's open a new terminal and run the ifconfig command to learn the IP address of Kali. We exceed the maximum character length. Right-click in the message box and select Inspect Element. Make the value of the max length more than 70. I think that'll be enough for this demo. So now I complete the IP address and sign the guest book. Here we have the second message, and the script code, which was in the body of the message, is executed in the browsers of each of the visitors. In the Beef control panel, we have a victim browser, that is Kali itself, because as soon as the guest book is signed, the script is executed in the browser. Now I go to my host machine and visit the XSS stored page. Now I have the second message. That means the hook script is executed in my host machine's browser. Go to Kali, and in the Beef control panel, my host machine is hooked. There are a few tabs in the Beef control panel. The main tab displays information about the hooked browser after you've run some command modules. Now the Commands tab is where the modules can be executed against the hooked browser. This is where most of the Beef functionality resides. Each command module has a traffic light icon. The green light indicates that the command module works against the target and should be invisible to the user. The command modules with a gray light means that they are not yet verified against this target. The yellow-orange light indicates that the command module works against a target but may be visible to the user. And the red light means that the command module does not work against this particular target. All right, let's run one of the command modules. In the Social Engineering folder, select the Pretty Theft command module. The module asks the user for their username and password using a floating div. You can use this module for Facebook, LinkedIn, Windows, etc. So I'll choose Facebook for this example. While my host machine is selected on the left panel, I click the Execute button at the bottom right-hand corner of the page. And look, we have a result in the Module Result History pane. So when we go to the browser in my host machine, we'll see the Facebook dialog box. Looks familiar, It says my session has timed out, and I should re-enter my username and password. Okay, let's log in. Go back to Kali, and in the Beef control panel, we have the username and the password values. Pretty slick, huh? To understand SQL injection, we should know basic terms of the database systems first. A database is an organized collection of data. It is a collection of schemas, tables, queries, reports, views, and other objects. A database management system, DBMS, is a computer software application that interacts with end users, other applications, and the database itself to capture and analyze data. A general-purpose DBMS allows the definition, creation, querying, update, and administration of databases. Well-known database management systems include Oracle, MySQL, SQL Server, PostgreSQL, etc. Structured Query Language, SQL, is a language used in programming and designed for managing data held in a relational database management system, RDBMS. SQL became a standard of the ANSI, American National Standards Institute, in 1986, and of the ISO, International Organization for Standardization, in 1987. Since then, the standard has been revised to include a larger set of features. Despite the existence of such standards, though, most SQL code is not completely portable among different database systems without adjustments. Here, there is a select query example. The SQL select statement returns a result set of records from one or more tables. A select statement retrieves 0 or more rows from one or more database tables or database views. Select is the most commonly used data query language, or DQL, command. In the example shown on the slide, we have a table named Client. Client table has 4 fields: name, surname, age, and gender. There are 4 records in the client table. In the select sentence, we want name and surname fields of the client table records, where the value of the age field of the records is greater than 30. So the result of this select sentence will be the name and surname values of these 2 records. There are a lot of code injection vulnerabilities as a result of the input and output manipulation, such as operating system code injection, XML injection, HTML script injection, object injection. Now, the most famous code injection is SQL injection. SQL injection is used to attack data-driven applications, in which nefarious SQL statements are inserted into an entry field for execution. For example, to dump the database contents to the attacker. SQL injection must exploit a security vulnerability in an application software. For example, when a user input is either incorrectly filtered for string literal escape characters embedded in SQL statements, or user input is not strongly typed and unexpectedly executed. In the SQL injection scenario, the parameter which is used to produce unexpected results is sent to the server. The parameter is not sanitized adequately on the server side. The server prepares the SQL string which will cause the unexpected result and sends it to the database management server, and the result is returned to the web server. The web server processes the query result, prepares the response, and sends it to the user. SQL injection attacks allow attackers to spoof identity, tamper with existing data, such as voiding transactions or changing balances, allow the complete disclosure of all data on the system, destroy the data, or make it otherwise unavailable, and become administrators of the database server. So here, there's a typical SQL injection example. We are in an online shopping site and would like to see a laptop. The URL for the laptop can be seen on the slide. The SQL query to bring the details of the laptop will be something like this. With an unexpected parameter, the SQL query becomes just like this. Now, what if we tamper with the ID parameter and send the ID string like this? Okay, suppose that we have a method to authenticate user login. Now, it looks like Java code, but it's not. It gives errors if you try to compile the method in any language. Please, just for now, focus on the algorithm. The method takes username and password as parameters and decides if the user can log into the application. It returns true if the user is valid, otherwise it returns false. So let's build the SQL query using the parameters which come from the login form. The single quotes are to start and end the string values in a SQL string. Plus signs are for the string concatenation. SQL string is executed, and corresponding records create the result set. The method returns false if no records are found, otherwise returns true and lets the user log in. If we enter user1 as a username and 1234 as a password, the SQL string will be select star from users where username equals user1 and password equals 1234. And the method will return true if there is a record matched, which means if there is a user named user1 and if this user's password is 1234. Now, suppose that we enter 1, single quote, or 1 equals 1, double dash as the password. Now the SQL string will be select star from users where username equals user1 and password equals 1, or 1 equals 1, double dash. In SQL queries, double dash means that the rest of the line is the comment and will not be executed. Here we use the double dash to get rid of the redundant single quote. Since 1 equals 1 is always true and the logical operator is OR, where clause will match for all the records of the users table, which means the size of the result set will be the total number of records in the table, and the method will let us log in even though we don't know the password. So let's make an SQL injection example. So for this demo, we use damn vulnerable web applications. Go to the OWASP Broken Web Applications homepage. Log into the application using user credential. Go to SQL Injection page. Now on this page, when we submit the user ID, that user's name and surname are displayed. If we try to submit a single quote with the ID number, we get a syntax error message. And we see that the database system is MySQL, and there is a redundant single quote in the SQL string, which means our input is not sanitized and the single quote has arrived in the database. Now, if we succeed to create a valid SQL string, we may get the results of that query. So let's submit this. 1 single quote or 1 equals 1 double dash space. The database system of the application, MySQL, requires space characters after the double dash, so don't forget to put a space after the double dash. And what do we have here? Now we have the name and surname information of all records. We found the SQL injection vulnerability and see the entire table's name and surname values in one go. So, if we can do this, what else can we do? SQLmap is a little bit complicated, but a very powerful command line application to exploit SQL injection vulnerabilities. You can download and use this free application in any platform, and it's embedded into Kali Linux. SQLmap has a lot of parameters, so you can use -h parameter to learn more. For now, let's build the SQLmap command. The first parameter is the URL. Since the program analyzes all the parameters, we don't need to give, but we know that the ID parameter is vulnerable. We can give it as the second parameter. Since we need to have a valid credential to reach the page in damn vulnerable web application, we have to give SQLmap a valid cookie. Not necessarily, but it is better to teach SQLmap when it gets a valid result. In this example, we can give a static part of the valid page, first name, and last, we have to say what we want from SQLmap. It says the banner is 5.1.41.3 Ubuntu 12.6_log. Let's ask for the current database at this time, --current-db. The current database is DVWA. Let's list the tables of the database. So here we go in deep. Let's dump the user's database. It says the database management system is MySQL. We already know it, so we can skip to other database management systems. In questions, the default answer is shown in all caps. If you hit enter, the default answer is selected. It says the ID parameter is vulnerable, so we can skip other parameters at this point. It found hash values inside the table and asks if we want to save it for further use. Moreover, it offers to crack the hash values. So let's use SQLmap's default dictionary in this example. And finally, we have the dump of the user's table, and hash values are cracked. Good job. Blind SQL injection is used when a web application is vulnerable to an SQL injection, but the results of the injection are not visible to the attacker. The page with the vulnerability may not be one that displays data, but will display differently, depending on the results of a logical statement injected into the legitimate SQL statement called for that page. This type of attack has traditionally been considered time-intensive because a new statement is needed to be crafted for each bit recovered. And depending on its structure, the attack may consist of many unsuccessful requests. Now, thankfully, there are several tools that can automate these attacks once the location of the vulnerability and the target information has been established. Now, we already know one of them. It's SQLmap. An SQL injection is a well-known attack and easily prevented by simple measures. With most development platforms, parameterized queries, also known as prepared statements, that work with parameters can be used instead of embedding user input in the statement. A placeholder can only store a value of the given type and not an arbitrary SQL fragment. Hence, the SQL injection would simply be treated as a strange and probably invalid parameter value. If the application is developed with an object-oriented programming language, using object relational mapping libraries avoids the need to write SQL code. The ORM library, in effect, will generate parameterized SQL statements from object-oriented code. A straightforward, though error-prone way to prevent injections is to escape characters that have a special meaning in SQL. In this section, we're going to talk about the authentication mechanism, flaws, and how to beat the authentication mechanisms. Authentication is the process of verification that an individual, entity, or website is who it claims to be. Authentication in the context of web applications is commonly performed by submitting a username or ID and one or more items of private information that only a given user should know. The authentication process can be two-sided. The user can verify the identity of the server while the server authenticates the identity of the user. The application should have a strong password policy and should have prevention methods to dispose of brute force attacks. The authentication methods are displayed in the slide. Since other methods have some disadvantages, the most commonly used authentication method is form-based authentication. Form-based authentications are flexible, so you can use different authentication factors together. In addition, they are able to be used with the proxies and firewalls, etc. In most cases, username and password values are used to authenticate a user. In this case, it's vital to have strong passwords. Therefore, the application should have a strong password policy. Here is an example for a good password policy. Password must meet at least 3 out of the 4 following complexity rules. At least 1 uppercase character, at least 1 lowercase character, at least 1 digit, and at least 1 special character. Password must have at least 10 characters, and you cannot use more than 2 identical characters in a row. For instance, 111 is not allowed. There are 3 factors in authentication mechanisms. 1. The knowledge factors, something the user knows, a password, partial password, passphrase, or PIN, etc. 2. The ownership factors, something the user has, an ID card, security token, cell phone with built-in hardware token, software token, etc. 3. The inherence factor, something the user is or does, a fingerprint, retinal pattern, DNA sequence, signature, face, voice, etc. And there are 3 types of authentication. 1. Single-factor authentication. As the weakest level of authentication, only a single component from one of the 3 categories of factors is used to authenticate an individual's identity. 2. Two-factor authentication. When elements representing 2 factors are required for authentication, the term is applied. For example, a bank card, something the user has, and a PIN, something the user knows. 3. Multi-factor authentication. Instead of using 2 factors, multiple authentication factors are used to enhance security. So, while trying to bypass authentication mechanisms, first, we try to find out valid credentials. For this purpose, let's first attempt to log in to the application using valid and invalid username-password pairs. Analyze the reactions of the application in case of different login attempts. Examine the error codes and error pages returned after these attempts. Try to reach restricted pages and see if there are adequate access controls. Examine the responses of the application. Don't forget to try the default username and passwords. We can use the username and password policies of the company who owns the application if we were able to find the policies while gathering information. In some of the applications, there are password recovery mechanisms, such as hidden questions. You should examine these mechanisms closely. If the answer space is big enough, for example, to fit the answer for what's your favorite color, is it big enough? We can talk about 2 basic types of online password cracking. Brute force attacks work by calculating every possible combination that could make up a password and testing it to see if the password is correct. As the password's length increases, the amount of time, on average, to find the correct password increases exponentially. As you see, the possibility to find a password using brute force attack is theoretically 100%. But cracking the password can take many years, depending on the password complexity. So, to make the possible value set smaller, it's better to use this method if we know something which will reduce the number of tries, such as the length of the password. Since users tend to use known words, in dictionary attack, we use previously prepared dictionaries to find the passwords. It's a smarter method compared to brute force attacks and reduces the number of tries dramatically. But in this case, finding the password is not guaranteed. You can find the password only if it's not complicated enough. It's possible to prepare sector-specific or company-specific dictionaries to increase the chance. So in brute force attacks, it's better to determine some of the rules first. For example, the password length will be between 3 and 8. It will contain just number and capital letters, etc. Suppose that we don't determine any rule. The brute force tool will try every possibility, starting with 1 character length password possibilities, and then 2 character length password possibilities, etc. In most cases, dictionary attack is chosen to crack a password. Because users have to remember their password, they generally choose passwords that are easily guessable and not complex enough. There are dictionaries that you can find online which contain the most frequently used passwords. There are a lot of tools that can be used in password cracking, and some of them can also be used in online password cracking attacks. So let's see an online dictionary attack. Here we'll use Burp Suite and Damn Vulnerable Web Applications for this example. Go to Login of DVWA. Suppose that we don't know any credential to log into the application. Run Burp Suite and turn off interception. We just collect the login requests at the beginning. Modify the browser proxy settings to use Burp as the proxy server. Make a few unsuccessful login attempts. Now go back to Burp Suite. Find a login request. Right-click on it and choose Send to Intruder. Go to Intruder tab. Go to Positions tab. Clear pointers. Point to the fields that we want to crack. Choose Cluster Bomb as attack type. In this type of attack, it iterates through each payload set in turn so that all permutations of payload combinations are tested. Go to Payloads tab. Choose Simple List as the payload type. Since we use the free version of Burp Suite, the tries are slowed down. So in this demo, we use handmade dictionaries which have a few words. Enter a few words for payload set 1, admin, administrator, user, user 1. Enter a few words for payload set 2, 1, 2, 3, 4, 5, 6, QWERTY, user, admin, etc. Go to the Options tab. Now let me bring your attention back to here, since the first responsive login attempt is a redirection. We choose Always in redirection. In grep match frame, enter a string which shows the login attempt is failed. So here it is, login failed. And don't forget to tick Flag Result Items. Go to Intruder menu and select Start Attack. And see what we have here? Admin and user credentials are not ticked as login failed because they are valid credentials. Now we can go to the login page and log in one of the credentials. Captcha, a backronym for Completely Automated Public Turing Test to tell computers and humans apart. It's a type of challenge response test used in computing to determine whether or not the user is human. It's used in login pages and in forms which have to be filled in by people, not by machines. Captcha implementations are often vulnerable to various kinds of attacks, even if the generated Captcha is unbreakable. The following vulnerabilities are quite common in many Captcha implementations. When the generated image Captcha is weak, it can be identified by only a simple comparison with an already broken Captcha. Another weakness occurs when the generated Captcha questions have a very limited set of possible answers. When the value of decoded Captcha is sent by the client, it is often encrypted by a simple algorithm and can easily be decrypted by the observation of multiple decoded Captcha values. Or the value is hashed by a weak hash function that can be broken using a rainbow table. Now, in two cases, you can be successful in reply attacks. First, the application does not keep track of which ID of Captcha image is sent to the user. Therefore, the attacker can simply obtain an appropriate Captcha image and its ID, solve it, and send the value of the decoded Captcha with its corresponding match. Second, the application does not destroy the session when the correct phrase is entered. By reusing the session ID of a known Captcha, it is possible to bypass a Captcha-protected page. Authorization is the function of specifying access rights and privileges to resources. More formally, to authorize is to define an access policy. For example, human resources staff is normally authorized to access employee records, and this policy is usually formalized as access control rules. During operation, the system uses the access control rules to decide whether authentication shall be granted or rejected. In the application, what resources the users will be able to use is determined by the authorization process. There might be different roles and users in the application, and every role has its own access privileges. We should identify each user or role, find out the permissions given to them, and try to push each user for unauthorized transactions. We try to find the weaknesses and vulnerabilities of the application's authorization mechanism and escalate our privileges. When the application does not control parameters coming from the user, you can process some unauthorized operations. The scenario displayed on the slide is a true story. The user has only view permission on the product. When she wants to view a product, the URL is prepared as seen on the slide by the application. Now there's a parameter named action, and its value is view. What if we change the value of the parameter as delete? Privilege escalation is the act of exploiting a bug, design flaw, or configuration oversight in the application in order to gain elevated access to resources that are normally protected from an application or user. The result is that a user with more privileges than intended by the application can perform unauthorized actions. If a normal user accesses functions or content reserved for other normal users, it's called horizontal privilege escalation. For example, Internet banking user A accesses the Internet bank account of user B. If a lower privilege user accesses functions or content reserved for higher privilege users, that's called vertical privilege escalation. For example, Internet banking user accesses site administrative functions. There are two real-world privilege escalation examples in this slide. In the first example, the message sent to a user has an ID number. Is it a random number, or is it a number increasing regularly? Here, the next message has the next number's ID. For instance, if the message ID is 12, the next message ID will be 13. Changing BID, we are able to read a message which is for anyone else. No matter what the ID number is, the application should perform an access control in each attempt. Now, in the second example, there is a hidden field with a name of list_admin and the value of F. Assuming that the F is for false, changing it to T for true, we get the admin role in that application. Path traversal attack is also known as .. directory traversal, directory climbing, and backtracking. This attack aims to access files and directories that are stored outside of the web root folder. By manipulating variables that reference files with .. sequences and its variations, or by using absolute file path, it may be possible to access arbitrary files and directories stored on the file system, including application source code or configuration and critical system file. It should be noted that access to these files is limited by system operational access control. So let's see the attack in a real-world example. While examining the application, we saw an attribute value pair with the attribute name of template. After just a few tries, we realized that there are different templates for the website, and the application decides which one to use. In the source code, it's seen that the value of the template attribute of the cookie is used as the file name directly. Change the template file name, put a few .. followed by etc. and password folders. Now here there are two things we should note. First, we assume that the server hosting the application is a Linux machine. Even though we don't know the operating system of the server, we can find it easily after a few attempts in this attack. The second, .. brings you one folder outer. We try to reach the root folder first, then go to the etc/password file. Redundant .. are harmless, which means if you send .. after you reach the root, no error is given. So you can put .. in as many times as you want. But you see, the response of the application contains password file content as well.
We're going to use OWASP Broken Web Applications and Kali for this demo. First, go to OWASP Broken Web Applications page. using its IP address or the domain name if you defined it in the host file. I use OWASP BWA.com domain name, which is mapped with the IP address of the host machine. Now, on the main page, I click BWAP link, which brings you to an extremely buggy web app. Log in to the app. The username is B, as in the insect, and the default password is bug. Now, there's a list inside the opened page. Find directory traversal file item inside the list, select it, and press the hack button at the bottom of the list. There's a message inside the open page that says, "Try to climb higher, Spidey." Okay, let's try then. When we look at the URL, we see the part page equals message.txt. Always be suspicious of these kind of input fields. Does the message.txt file point directly to a file inside the server? What if I change the file name or path? To understand what happens when I try to reach another file inside the web server, let's make a little preparation before. Go to OWASP BWA virtual machine. Go to root using cd or cd/linux commands. I want to create a text file here. Echo Linux command writes the text given as the parameter. Here our text is, "We have an alternative!" The greater than character redirects the output to the target, and I give the target as mymessage.txt. Check the file with the cat command. We see that it contains our message. Now let's go back to the BWAP app and try to access this mymessage.txt file. I put the file to root, so I have to navigate to root first. In Linux systems, // characters are used to bring you to the outer folder. If you put enough numbers of // characters, you can reach the root folder. What happens if you put // characters when you're at the root? Well, absolutely nothing. So you can put // in as many times as possible. Then write the file name you want to access, mymessage.txt, and hit enter. As you can see, the text on the page has changed. We have an alternative. That means we accessed an arbitrary file inside the web server. Now we can try to access the critical systems files. Since // worked fine, we'll assume that the operating system of the web server has a Unix or Linux or BSD-based operating system. Because Microsoft operating systems use the / instead of the /. Let's try to access the password file under the etc folder. Voila! We can read the password file. /etc/password is a text file that contains the attributes of each user or account on a computer running Linux or another Unix-like operating system. What else? Can we reach the shadow file? The /etc/shadow file stores actual passwords in encrypted format for users' accounts with additional properties related to user passwords. No, we cannot access the shadow file with the privileges of the current user.
Now, as we mentioned before, HTTP is a stateless protocol. That means two requests sent from the same client has absolutely no relation. But today, the websites are mostly interactive and status information. That is, the information that is required for the user to be recognized during HTTP requests is of vital importance. Because the HTTP protocol does not contain such information by its design, software engineers have developed their own methods to provide session management. The most important and most widely used of these methods is that unique session information generated by the server is sent to each client individually, and the clients introduce themselves to the web server and hence the web application, using this unique information in following HTTP requests. While session management had to be implemented by developers in the past, most of the tasks are now handled by application servers. And so the developers have been saved from such an important and difficult responsibility. But don't give up hope. Developers still have to manage some important tasks of session management, such as starting and ending the session. Mistakes done in session management allow us to perform some attacks. We will see the most important of these attacks in this section. There are a few methods to manage sessions, such as URL rewriting, hidden form fields, special HTTP headers, or SSL keys, but the most popular session management method is the use of cookies. When the client sends a request to the application, if the client does not have a valid session token at this time, the server returns a session token in setCookieHeader. After this time, the client sends its requests with this session token in the cookie, and the server identifies the client with this information. Now, as we said before, the use of cookies is the most popular session management method, and cookies contain session tokens. Session tokens contain session IDs and some other information. Session IDs are the unique identifiers that are used to identify the users. One of the attacks against session management is that the session information generated on the server side is predictable. This is usually caused by the following situations. First, using sequential session IDs. It's not seen that much today. Second, using weak random number generators. There are some weak random number generators that just shouldn't be used anymore. These methods are not intended to generate unique numbers. And third, using short session IDs. If the session ID is not long enough, it might be the subject of a brute force attack. So, session ID has to be renewed by the application when the user logged in. If the session ID is not renewed, we can perform the session fixation attack. The attack scenario is as follows. Attacker visits the application which has inadequate session management and gets a valid session token. Then, he prepares a link to the application which contains the session token and sends the link to the victim, for instance, in a phishing email. Since the link is to a trusted website, victim does not suspect the link and clicks it, and logs into the application using his own credential. The application identifies the victim, but doesn't give him a new session ID. So after this time, when the attacker visits the application with the same session ID, he is now victim on the application.
Let's see the session fixation attack in action. We're going to use OWASP Broken Web Applications and Kali for this demo. First, go to OWASP Broken Web Applications page using its IP address or the domain name if you defined it in the host file. I use OWASP BWA.com domain name, which is mapped with the IP address of the host machine. On the main page of the OWASP BWA app, click OWASP WebGoat link. Authenticate using /OWASP BWA credential. Click the Start WebGoat button at the bottom of the page. Now on the tree at the left-hand side of the page, expand Session Management Flaws node and select the Session Fixation link. In this scenario, victim Jane has an account in Goat Hills Financial, and the web application of the finance service is vulnerable to session fixation. Now, in the first stage, you're Hacker Joe. You'll prepare a phishing email as if it's sent by Goat Hills Financial, and it will contain a link where the session is fixed. In the explanation stage of stage 1 on the web page, we know that the name of the session ID variable is SID. Find the link inside the prepared email and change it with a valid link first. Then put an ampersand at the end of the URL to add a new parameter and type SID equals session for Jane. Now, session for Jane is an arbitrary session ID given by me. You can give it anything you want, just don't forget it. To send the email to the victim Jane, click the Send Mail button. Now we're in stage 2. We are the victim Jane in this stage who has got an email from Goat Hills Financial. The email contains a link. When we bring the mouse pointer on the link, we see the URL address that the link points to. It is a legitimate Goat Hills Financial link, so the victim clicks the link with no doubt. But the SID is set by the hacker at this point. In stage 3, you're still the victim, Jane. When Jane clicks the link, the login page of Goat Hills Financial opens. As it's seen in the explanation of Stage 3, you can log into the app using Jane/Tarzan credential. Did you see the session ID parameter inside the URL? Enter the username and the password and click Login. Now we are in the final stage. We are now Hacker Joe. It's time to steal the session of Jane. Try to go to the web page of Goat Hills Financial. Now, since Hacker Joe does not have a valid session, the app redirects him to the login page. Look at the URL. The session ID of Jack is no valid session. Change it with the session ID with the one you sent to victim Jane. In my demo, it was session for Jane, and hit enter. Now, as Hacker Joe, you're inside the Goat Hill Financial's website as Jane.
Another attack against session management mechanisms is cross-site request forgery, CSRF attack. CSRF is an attack that forces an end user to execute unwanted actions on a web application in which she is currently authenticated. In this attack, the attacker has no way to see the response to the forged request. The attack scenario of CRF is as follows. User visits his online banking website, which has CRSF vulnerability. He realizes that the website is a brand new interface. He can't find the money transaction function in the new interface, opens a new tab on the browser, and searches for the words, "How to use the new interface of my bank." He finds a website about the new interface of the bank, which is prepared for the attacker who already knows about the CSRF vulnerability of the bank website. The page of the attacker's website contains a request to the bank website, and it's about the money transfer from the user's first account to the attacker's account. So when the user visits the attacker's website, he sends the money transfer request to the bank without realizing it. So there are three things we shouldn't miss in this scenario. 1. The bank's website is vulnerable to CSRF. 2. The user visits the attacker's website while he is logged in to the bank website. And 3. The attacker won't see the response of the money transfer request. Does he really need to see it? He will see the response in his bank account. So quickly, how is a CSRF vulnerability exploited? Go to Damn Vulnerable Web Application in OWASP Broken Web Applications. Log in using admin credential. Click the CSRF link on the menu. We're on a page to change the password of the admin user, and current password's not even asked. So let's change the password, for example, 123. Now log out and log in again. We see that the password of the admin user is changed. Now again, go to CSRF page. Create an HTML file on the desktop. This is the malicious website that the hacker tries to make the victim click on. View the source of the CSRF page of Damn Vulnerable Web Application. Copy the part which is to change the password and paste it in the HTML file you created on the desktop. With this example, first, the victim needs to click a button to exploit CSRF vulnerability. Clear the redundant parts. It's not necessary, but this is just to purify the demo. Fill the request action clearly. Change the input type as hidden, because we don't want to display any field to the victim. Give the input value, for example, 1111, in both the new password field and the password confirmation field. Save the file. While you're logged into Damn Vulnerable Web Application, open a new tab on the browser and open the file you prepared. You can open the file by dragging and dropping it onto the tab. When you click the button, you will see the password change page and the message which says the password has been changed. That means we succeeded to change the password of Damn Vulnerable Web Application from another website. Now, if you try to log into Damn Vulnerable Web Application using 123, you cannot, because hackers changed the password to 1111. So, with a little help of scripting, we can eliminate the button phase easily, so a simple visit of the victim will be enough to change the password. Give an ID and name to the action. Change the password to understand if the attack succeeds, for example, 1. Make the change input type hidden. Now, let's write the script code which triggers the action we wrote. Save the file. When you're logged in to Damn Vulnerable Web Application, open a new tab on the browser and open the file you prepared. Again, you can open the file by dragging and dropping it onto the tab. In this case, you will see the message, "Password changed," as soon as you open the page. When you want to log into the application again, you will see that the password is no longer 1111.
In this lecture, you'll learn the types and methods of information gathering, the classic information gathering methods such as Whois and banners, how to use search engines to gather information, how to gather information about the people who are related to a target company, how to find more from the archives, and the tools to help you collect valuable information about the target company. The first phase in security assessment is focused on collecting as much information as possible about the target. Information gathering is one of the most critical steps of hacking or penetration testing. The more information is gathered about the target, the more it becomes possible to customize the attack. In this section, we're going to answer these questions. What can we learn about the target over the Internet? How can we collect the information? Where can we find the information about the target? Before we begin, we should answer a basic question. What is the target? Target is the company, institute, network, system, or even a person that we want to hack. An application, a person, a system. We'll try to collect every bit of information that helps us to hack the target. There are two types of information gathering. The first type is passive information gathering. In this type of information gathering, you don't want to be detected by the target. In this regard, you don't use tools that send traffic to the target, neither from your host nor an anonymous one across the Internet. Passive information gathering activities may include, but are not limited to, identifying IP addresses and subdomains, identifying external or third-party sites, identifying people who are related to the target, identifying technologies, identifying content of interest, identifying vulnerabilities. You can collect information passively from web archives, mail archives, social networks, search engines, etc. A second type is active information gathering. In this type of information gathering, you scan on the target systems. Active information gathering requires more preparation for the attacker pen tester because it leaves traces which are likely to alert the target or produce evidence against him in the course of a possible digital investigation. There are a lot of places you can collect data over the Internet. Web archives. Suppose that a sensitive data was published accidentally. A few days later, the admins realize the mistake and remove the data from the website. But what if someone has already archived that website with the sensitive data? Scanning the ports and services, you can find the ports accessible over the Internet. The target company opened that service, intentionally or unintentionally. Using search engines, you can find enormous pieces of useful information. Beyond the known weaknesses, leave traces on the websites, on headers, titles, URLs. You can easily find these traces using search engines. You can find some useful information about the target company on social networks, for example, Facebook, Twitter, or LinkedIn. Suppose the target company is looking for a new system admin to hire. Look at the job sites or LinkedIn. What would you see? The information about systems that are used in the target company? Or tools and programs used to monitor those systems? Look at the experts working for a target company carefully. Do they subscribe to forums or mail lists? What kind of problems do they share on this forum or these mail lists? Asking for help about Java version 9 or Hibernate framework. You take and publish pictures of your secret disaster recovery center on your website. You're sure that it's impossible to understand from the picture where the center is. Are you sure? What about the metadata of the picture? Did you choose the location info? Whois is a web application used to get information about the target website, such as the administrator's email address, details about the registration. Whois is a very large database and contains information of approximately all the websites. It can be searched by domain name or an IP address block. The protocol stores and delivers database content in a human-readable format. You can use the Whois command of Linux systems to get the Whois query results. In addition, there are some websites that help you to get the Whois query results. You see some of them on the slide, and Whois Service of Domain Tools websites is also given as an example. If we analyze the banners of the response sent by the web systems of the target company, we can find some detailed information about the server, the technology used, etc. We send a request to port 80 of nhs.uk website using Telnet services and get the response. Look at the server and the X-powered by headers. We learned that the application server of nhs.uk is Microsoft-IIS version 8.0 and ASP.NET. It's used to develop the web application. But hold on, are we sure? Could the information be fake? While the search engines are the most typical examples of crawlers, and they let us run queries on the websites, search engines are very useful to collect information about the target in depth. Using search engines, you can find enormous pieces of useful information about the target company. Names of the employees, accessible services of the systems, files, or folders which contain sensitive data, login pages. Beyond the known weaknesses, these leave traces on the website, on headers, titles, URLs. You can easily find these traces using search engines. Google hacking, also named Google dorking, is a computer hacking technique that uses Google Search and other Google applications to find security holes in the configuration and computer code that websites use. Google hacking involves using advanced operators in the Google search engine to locate specific strings of text within search results. Some of the more popular examples are finding specific versions of vulnerable web applications. Some of the advanced operators of Google search engines are shown in the slide. You can see the details of advanced search in Google at google.com/advanced_search. You can find a lot of specific queries on exploit-db.com/google-dorks. Using these queries, you can discover web application vulnerabilities, files containing username and/or passwords, sensitive folders, web services, error messages that disclose sensitive information, log or backup files, devices such as printers or CCTV cameras that are accessible over the net, and more. For example, you can find a username and password list from front page servers by writing the keywords shown on the slide in the Google search field. Here, there are a few examples to show how we can use Google Advanced Search to find valuable information. For example, if we do a search with the words inurl:/co.uk and inurl:/admin, we can find administrative panels of the websites which have .co.uk superdomain. Originally created by Johnny Long of Hackers for Charity, the Google Hacking Database, GHDB, is an authoritative source for querying the ever-widening reach of the Google search engine. In the GHDB, you'll find search terms for files containing usernames, vulnerable servers, and even files containing passwords. When the Google Hacking Database was integrated in the exploit database of offensive security, the various Google dorks contained in the thousands of exploit entries were entered into the GHDB. The direct mapping allows penetration testers to more rapidly determine if a particular web application has a publicly available exploit. There are some tools to help you use a GHDB and more. SiteDigger is one of them. When Foundstone was acquired by McAfee, it's now published as one of the free McAfee tools. McAfee Foundstone SiteDigger is an automatic tool which helps you run the queries of GHDB on the target website. In addition, Foundstone has its own database like GHDB, and it's called FSDB, the Foundstone Database. SiteDigger is a native Windows application and requires .NET Framework version 3.5. Simply select the queries, enter the site or domain name, and press Scan. Search Diggity is the primary attack tool of the Google Hacking Diggity project. It is Bishop Fox's MS Windows GUI application that serves as a front end to the most recent version of our Diggity tools. Google Diggity is the traditional Google hacking tool. Bing Diggity is Bing equivalent of the Google hacking tool. BHDB 2.0 is the new Bing hacking database, now as effective as Google GHDB. Bing Link from Domain Diggity is Bing footprinting tool based on offsite links. Code Search Diggity is the open source code vulnerability scanning tool. DLP Diggity is data loss prevention scanning tool. Flash Diggity is Adobe Flash security scanning tool. Malware Diggity is malware link detection tool for off-site links. Port Scan Diggity is the passive port scanning via Google. Shodan Diggity is an easy interface to Shodan's search engine. Bing binary malware search is to find malware via Bing's indexing of executables. Not in My Backyard Diggity is to find your info easily in third-party sites. When you run Search Diggity, you see all Diggity tools as separate tabs. Let's see Google Diggity first. Select the queries you want. You can select all the queries by ticking the root object, or you can tick the nodes one by one. Go to Sites/Domain/IP Ranges section and add the target websites. In Search Diggity, you can scan using proxies. This is to help you avoid bot detection of search engines. In the Settings section, you can arrange the speed of querying. To avoid bot detection, scan as slowly as possible. When you start the scan, you will see that Google detects bot activity and blocks your queries, so Search Diggity pauses the scan for 15 minutes. Now let's see Bing Diggity. Same as Google Diggity, you can add target websites on Sites/Domain/IP Ranges. Let's slow down the scan at this time on the Settings section. Select the queries you want and start the scan. Bing detects the bot activity as well as Google, but it takes a few minutes. You can collect some results in this period. Shodan is a search engine for Internet-connected devices. Shodan gathers information about all devices directly connected to the Internet. If a device is directly hooked up to the internet, then Shodan queries it for various publicly available information. The types of devices that are indexed can vary tremendously, ranging from small desktops up to nuclear power plants and everything in between. How is it different from Google? The most fundamental difference is that Shodan crawls the internet, whereas Google crawls the World Wide Web. However, the devices powering the World Wide Web only make up a tiny fraction of what's actually connected to the internet. Shodan's goal is to provide a complete picture of the internet. You can use the search parameters displayed in the slide. Country. Use the country code you want to look for. For example, use GB for Great Britain, US for United States, etc. City. Filters the results according to the specified city. Geo searches in a given location. Hostname filters the results according to the host or domain name given. Net searches in given IP or subnet range. OS filters the results according to the operating system. Port searches for specific ports. Before, after filters the results according to the date. Show the results which are before or after the date given. As a plus, you can see the current Shodan scans on ics-radar.shodan.io. Let's try to find out the accessible Cisco device interfaces in Great Britain. In the search box, search for Cisco and last modified words. Use country. Search the parameters with the GB code. Now you can use the country code in double quotes, otherwise don't let any space occur between the country, parameter, and GB code. When you start the search, you'll see the results in a few seconds. Surf on the results. You will probably face the login pages of Cisco interfaces. You've already found something. You can perform, for example, a brute force attack on the login page. If you're luckier, you can find a Cisco Device Manager interface like the one seen on the slide. People who are related to the target company are always one of the most important resources to collect information. Here's a stunning example. In September 2017, The Guardian reported that Deloitte suffered a cyber attack that breached the confidentiality of its clients and 244,000 staff, allowing the attackers to access usernames, passwords, IP addresses, architectural diagrams for businesses, and health information. A developer working for Deloitte as an outsource put the credentials to GitHub so anyone who visits his GitHub account could see the credential to access the critical systems of Deloitte. Now, you think this single example is enough to show that searching for people who are related to target company is one of the most important parts of information gathering? In which social network platforms do they have accounts? What do they share? Etc. While you're collecting the information about the target company, you're going to find the people who work for it. You can find more about those people using PIPL.com or PIPL website. With the world's largest people search engine, PIPL is the place to find the person behind the email address, social username, or phone number. PIPL is a people search engine that tries to be a little different. Rather than just go off and hunt for email addresses, this tries to search through the deep, invisible, hidden web to return contents that other search engines are going to miss. The interface is simple. Type in the name, email address, social username, or phone number, optionally city, state, and/or country, then let it go to see what it'll find. If you find usernames or nicknames while collecting data about the target company, you should investigate if the username or nickname is used in social networks. Instead of trying the social network platforms one by one, you can use CheckUsernames.com's website.
CheckUsernames.com searches the given username on 160 social networks. Go to the social network platforms where the username or nickname exists. Look at the profile of the user to learn more about the person from the target company. Now, if you somehow got the password of a person from the target company, you can try the password in social network platforms. If the person used the same username or password in any social network platform, most people do, you can compromise that account. Now, attention here. Try the username and password values to compromise the social network platform accounts only if you are allowed to do it. Even though the penetration test agreement between the company and you allow it, in most countries, you're not allowed to do this. It's a good approach to look at the archives or backups of the systems. You'll probably find some valuable data in those archives. The Internet Archive is a San Francisco-based nonprofit digital library with the stated mission of universal access to all knowledge. It provides free public access to collections of digitized materials, including websites, software applications and games, music, movie, videos, moving images, and nearly 3 million public domain books. Web.archive.org is the archive of the website served by Internet Archive Library. Simply, write down the URL of the target website. You'll see a timetable. If you select a year from the timetable, you'll see the archive dates of the target website in details. On the side, you see the date in which the target website is captured, there in green circles. Suppose that a sensitive data was published on the target website accidentally. A few days later, admins realized the mistake and removed the data from the website. But what if someone has already archived that website with the sensitive data? Select a year, click a date which is in the green circle. You'll see an old version of your target website. That's what the nhs.uk website looked like on the 1st of May 2010. Footprinting, also known as reconnaissance, is the technique used for gathering information about computer systems and the entities they belong to. To get this information, a hacker might use various tools and technologies. FOCA, Fingerprinting Organizations with Collected Archives, is a tool used mainly to find metadata and hidden information in the documents it scans. These documents may be on web pages and can be downloaded and analyzed with FOCA. It's capable of analyzing a wide variety of documents, with the most common being Microsoft Office, OpenOffice, or PDF files. These documents are searched for 3 possible search engines: Google, Bing, and DuckDuckGo. Here's how you can download and install FOCA. You can download FOCA from the 11 Paths website that is seen on this slide. FOCA is open source. You can download all the sources as well as the executable binary from github.com/11paths/FOCA. However, this version requires SQL Server Express installed on the host machine. So I prefer to download and use the previous version of FOCA, which requires .NET Framework version 3.5 only. It's a portable version, so you don't need to install it. Download the zip file, extract it, go to the bin folder, and run foca.exec file. That's it. To work with FOCA, start a new project using Project button on the upper left corner. Give the project a name, enter the website, and choose the folder to save the results to. When you finish filling the fields, click the Create button to create a new project. After creating a new FOCA project, we can start a network scan. From the tree at the left side, select Network Node. Now select the search types. The search types listed on the panel are Web Search, you can choose whether Google or Bing, DN Search, Dictionary Search to perform DNS search using a dictionary, IPBing to serve the domain names hosted on the same IP address, Shodan and RobTex queries, and click the Start button to start the scan. Now we can collect some documents published by the target domain to collect their metadata. From the tree at the left side, select Metadata node. You're supposed to see a panel similar to the one which is seen on the slide. Select the document types you want to collect, and click the Search All button to start the document search. You can see the documents found under Metadata node of the tree. You should download the documents to be able to extract the metadata. Right-click the documents you want to download from the menu. Select Download. Now you can extract the metadata of the downloaded documents. You can understand if a document is downloaded from the Download column of the table. Select the documents that you want to collect the metadata. Right-click and select Extract Metadata from the menu. You'll see the results under the Metadata node of the tree. Let's see FOCA in action. Find the 11 Paths FOCA website. On the website, you see a download button which brings you to the GitHub page of 11 Paths. You can find the latest release version of FOCA under FOCA Releases folder. It requires SQL Server Express installed on the host machine. Go back to the 11 Paths website. You can find a link to the previous version of FOCA. Read and accept the EULA and download the focapro.zip file. Extract the zip file. Go to bin folder and run foca.exec file. On the project menu, select New Project to create a new project. Fill the boxes in carefully. And then click Create. Save the project file for further usages. Now we can start a new scan. Select the network node from the tree. Select the search types. On the dictionary search panel, you have to choose a valid dictionary. The default path is probably not valid. You can find a valid dictionary inside the DNS dictionary folder, which is under the bin folder where you found the foca.exec file. Click the Start button to start the scan and let the scan continue for a couple of minutes. Let's collect the documents from the target website and extract their metadata. Select the metadata node from the tree. Select the document types you're interested in. And click Search All button to find the documents. Let the search continue for a couple of minutes. Select the documents that you want to collect the metadata. Right-click and select Download. Select the downloaded documents, right-click, and select Extract Metadata at this time. Look at the nodes under the metadata node of the tree, and you will see the metadata extracted from other downloaded documents. You can examine the metadata of each document one by one, or you can find valuable data summarized under the metadata summary node. Usernames of the owners of the documents, operating system where the document is created, email addresses collected from the metadata of the documents, and more. Maltego is an interactive data mining tool that renders directed graphs for link analysis. The tool is used in online investigations for finding relationships between pieces of information from various sources located on the Internet. The focus of Maltego is analyzing real-world relationships between information that is publicly accessible on the Internet. This includes footprinting Internet infrastructure as well as gathering information about the people and organizations who own it. Maltego can be used to determine the relationships between the following entities: people, names, email addresses, and aliases; groups of people, social networks; companies; organizations; websites; Internet infrastructure such as domains, DN names, net blocks, and IP addresses; affiliations; documents and files. Connections between these pieces of information are found using open source intelligence, OSINT techniques, by querying sources such as DNS records, Whois records, search engines, social networks, various online APIs, and extracting metadata. Maltego provides the results in a wide range of graphical layouts that allow for clustering of information, which makes seeing relationships instant and accurate. This makes it possible to see hidden connections even if they're 3 or 4 degrees of separation apart. You can download the Maltego CE, that's the Community Edition, from www.paterva.com, and it's embedded in Kali Linux. Let's see Maltego in action. Go to Kali Linux and open a terminal screen and type Maltegos, that's Maltegoce, to run Maltego Community Edition embedded. First, we choose a machine to run. There are different machine options specified for different purposes. For example, there's a Twitter Digger machine to work on a Twitter account and analyze the tweets. Let's choose Footprint L1 machine this time, which is a fast and basic footprint for the target domain. The second step is to specify the target domain. When we click the Finish button, it's going to start to collect data. Now, in the Community Edition of Maltego, the results are limited to 12 entries. It shows the results in graph mode. We can zoom out to see the entire picture or zoom in to focus on specific results. Now, if you select a node and right-click on it, you can see all the transforms you're able to run for that node. Transforms are grouped according to their purposes. You can expand a group and select a single transform to run, or you can run a group of transforms at once. You can configure a transform before the run or save a transform in your favorites list. Let's run the mirror:\email addresses found transform at this time. The results start to come in about a minute. Let's see some more about Maltego while we're waiting. There are different graph types you can choose to see the results. If you zoom out the graph under 30%, the entities are shown as the dots instead of meaningful symbols. All the colors of the dot point to a specific type: email addresses, websites, domain names, and more. You can see the color legend in the lower right corner. The results of the transform we ran a minute ago are here now. You can use the toggle full screen button or simply press Alt plus Enter buttons to toggle the graph to full screen. You can select the email addresses node and see the collected email addresses listed in the Detail View window.